Hey, welcome to the show. I'm just Bret. Just today, no co-host, but I do have a good friend on the show. So we're going to get to it real quick. As you can see, I'm excited because we've been chit-chatting for the last half an hour. I wish I had the pre-show recorded because that's sometimes some of the best stuff. But you know the drill. If you've been here before, this is a live show I do every Thursday now, going on almost 7 years, I think, since 2018. So maybe 6 years. Anyway, we're about to hit 300 episodes. I'm very excited about that. That'll happen this year. And we've got some stuff. Hey, Cristi's on the show. But before we get to that, I just want to let you know we have a podcast. So if you want to listen to a lot of my guests live, in fact, we're not even sure if this week will get turned into a show. Cristi and I will talk about it later. Whether or not this will be good as a podcast, I think it's going to be great podcast content, but we'll see. You can get the podcast on my website, and then you can join our Discord server, which is right above me. And then you can come back weekly to talk to our guests and hang out with Nirmal and I. Nirmal is actually away at another conference today, so he wasn't able to be here. But let's get into it. Instead of all the usual pre-show, post-show stuff, let's just jump into it. So the conversation today is talking about implementing DevOps tooling, picking DevOps tools, what's the right one, implementing, or maybe just stepping back and looking at some of the pains of DevOps. And I have my friend Cristi, I'm going to try it this time, Cotovan on the show. I practiced it a little bit, but Cristi, thanks so much for being here.
Hey, thank you, Bret. Thanks for having me. I never thought I'd be in a show ever.
Yeah, so in case you didn't know, Cristi is my fantastic editor for years now, like 3 years or something. It feels like it's been a while.
At least.
So if you listen to this podcast, or if you've looked at any of the clips that we come out with these shows, Cristi's your guy. He's the one doing it. Him or his little band of happy helpers at home. This is all brought to you by Cristi Editing Services. So let's talk real quick. I just want to sort of talk about a little bit about what you do. You are also a YouTuber here. You have your own channel, right? Let's bring that up.
Yeah, I have a YouTube channel. Yeah, go ahead.
Yeah. Oh no, I was good. No, please do. Tell us everything.
No, I've been a developer most of my life, but I also dabbled in design, graphics, and all that stuff, and then video editing and media production, whatever. So in recent years, I have tried to develop this kind of side show of mine where I do coaching, training, video editing, tutorials, all those things, courses, and taking on video editing work, such as yourself. So, yeah. But my day job, as it were, is a developer for a multinational organization. I have developed a CMS, an e-commerce platform from scratch, starting in about 2002. And then, that's a platform that's used in about 20 countries today. And we are now, I'm going to tell you about our plans later when we actually start. Yeah, I don't want to divulge too much.
Well, everyone say hello to Cristi. So yeah, he's just a swell guy, and it's like a lot of us have the day job, and then we have hobbies that turn into second jobs, and and Cristi's he's actually got a couple of things. I just want to promote this stuff real quick. If you're someone who's looking into making your own videos, whether it's YouTube or doing your own podcasting or doing anything in a video editor, Cristi actually has courses on that. He actually has something called the Media Makers Club that you can join for support. And I think you focus mostly on two editors, right? Descript and Camtasia, right?
Yes, at the moment, yes. I'm trying to work on bringing new ones, such as DaVinci Resolve, Premiere, but primarily these two, yes. A lot of people want to learn those, and I like to teach them.
Yeah, and you've got tons of videos. I mean, over 342 videos on a lot of this stuff. So I probably need to watch more of these than I do because, I'm living a content creator life. So
your third or fourth job, which part of which job is that going to be?
Yeah, I mean, and it was just great to get a video editor on board our team that actually is a developer, so you understand at least some of the terminology that's coming out of a DevOps engineer's mouth.
Yeah.
That's awesome, I feel like, and that's something that's so rare. I mean, it's pretty rare to get someone who's video editor and developer. So you're one of a sort of an elite crew of people.
That makes
So
me a
yeah,
difficult client customer for these particular tools that I used, Camtasia and Descript. I always complain about their bugs and their limitations and all those things. So I think they hate me. I have like 150 tickets open.
that's
I am
funny.
not pleasant to be with.
Well, yeah, that's the thing about engineers is we notice the little things and we were like, oh, they can fix that. That's easy. Or
Yeah,
that shouldn't be that way. I do not approve of this particular feature or change. So,
you have no idea
uh,
how many times I've said this. This is a small improvement. It will probably take a developer 5 minutes. How do you know it's 5 minutes? I know, because I am also a developer. Come on, just get some guy to do it.
yeah, and this kind of leads us into the discussion for today. And so the way this all came about for you all watching live, and thank you for being here. The way this came about was Cristi is onboarding for his day job as this longtime developer of a product that you probably, I mean, if you've written most or all of it, it is like your baby. Like you know everything about it. You made all these decisions years ago. You know why those decisions were made, and that's actually pretty rare on software projects I work with. Typically, I'm working with teams that weren't there when it was first created, and so there's a lot of context lost. And why did we choose this port? Why did we try this? Why did we choose this database thing? And so it's always nice to find someone who's there from the beginning, has all that context. But a challenge of that, and we're going to get into it today, is that the challenge nowadays is that every decision tends to need to be rethought out every decade. And we are now in sort of the container decade. For the last over 10 years, we've had Docker and Kubernetes. And that what came out of like the beginning of the DevOps movement, where we needed to be able to package up, test, and deploy applications, not just once a year, which, I mean, you and I think we both came from those worlds of long software update life cycles. We all get Office 2000 and then Office 2004 or 2003 or whatever it was, right? Windows came out every 3 or 4 years like that. So that whole culture really shifted in the late 2000s. And then this DevOps movement of deploy early, deploy often, and then measure everything that you're doing so that you know if you're getting better or not. That kind of started to take over in the internet crowd in like 2000, 2001, or not, sorry, not 2000, 2009, 2010. And I didn't even really figure out this stuff until like 2013, 2014, where I started having clients that were all in AWS and they needed to deploy every day. And we realized we needed a much faster tooling system, and we had far less open source software back then than we do today, which is also the challenge of choice that we're going to get into. So we're going to do two things, I think, today. One is obviously I want everyone's questions about learning DevOps, what you're struggling with and implementing today. I'm going to try to help Cristi through some of his decisions. We're going to talk about Docker and traffic and local tooling versus server tooling and all that stuff. But I also definitely want us to take your questions for discussion, because I feel like Cristi's in the middle of it. Like you're totally in the weeds. And that's like to me, that's one of the perfect moments to pull someone out and say, okay, what sucks? What's frustrating? How can we help? But also, it's these tools that we're now implementing that I think is a theme of the conversations Cristi and I have. There is a shift in thinking as well as a shift in the tooling. And it's not just that we're adopting a new tool to solve the same problem. We actually have new problems now that we didn't have 15 years ago, right? We're now not just running software in one place. We're running it in lots of places. We now have multiple architectures that we have to run on because some of us are on Apple Silicon. Microsoft just announced this week that they're going all in on ARM for Windows, which that was sort of like a duh for the last 4 years. Is once we saw what Apple could do with it, we're like, yeah, Microsoft's going to have to catch up. We just had Graviton on the show last week or the week before. So AWS is Graviton, which is all AWS. So now we have to compile for multiple architectures, multiple operating systems typically, especially if you're client side. And there's more open source languages and frameworks than ever before. So that's like one of the huge challenges of anyone is figuring out if I'm getting started, what path do I take? And I have diagrams we can talk about and dive into. But first, let's get questions from the audience so we can line those up. So if you're all are, Max is back, by the way. Hello. Martin's here. Unsecure. What's up? Sorry, I'm gonna totally mispronounce this. Robesberry. Sorry if I mispronounced that. I'm totally way off on that. I'm actually curious. From Mexico. Great. Glad to have you. And who else is here? Did I miss someone up front? Todd is here. And Sinaroth. Sorry if I mispronounced that. Sirinoth. I have to say that 4 or 5 times. Yeah, my major pain is that I spend more time learning than working on it, and I'm anxious that I'm always behind. How do I identify enough levels of training to work before pursuing certifications? There's like 3 questions there, even though there's only 1 question mark. Spending more time learning than working on it. That's actually, I feel like, Cristi, that's like a theme you were just talking about. Like, how do you know which things to use? How do you know which things to learn?
Yeah, that's.
What are your thoughts?
Well, yes, that is a first challenge that I think I hit every day, because you try to drink from a fire hose, really, when you're trying to move from let's say a monolithic, because that's where we are now. This application that we built all of these years, for which I was a sole developer for most of it. And then you build something and you think, okay, if I'm going to have to rebuild this, it's going to be a significant investment of time, effort, all the time, while I can't work on something new or some whatever bug fixes. I don't know. So this is our path now, trying to move from monolithic to microservices, break it down, because largely the framework, .NET framework that we were using, is going to be deprecated very, very soon. So also making things more scalable and all that stuff. So it's very difficult to figure out, what should I learn first? I mean, I know Docker. Okay, we want to do Docker. Fantastic. That's what we want to do. Then how does that work? What do I need for that? Okay, do I need .NET? Do I need, I don't know, for databases, PostgreSQL? Okay, great. Let's learn that. Oh, by the way, I need to launch it and run it in on a machine itself, because they don't recommend doing it in a container, all that stuff. Okay, well, all right. What do I need? Do I need GitHub? Yeah, I need GitHub. I need Docker Hub. Do I need Docker Hub? Do I need that? I don't know. Probably I do. I'll put a migration tool up there. Then what do I need? How do I connect to it? How do I map? Oh, you need traffic. Oh, so who said that? Well, someone says that you need traffic. All right, well, let's learn that too. So like everywhere you turn, it seems you can't make any headway, because you keep bumping into these tools you need to learn from scratch. That is really my main frustration.
Yeah. Well, yeah, I mean, and by the way, this is the same problem. Like, what you're describing is just a problem of being in technology as an engineer, right? Is that because on the Windows side, you have the same problem. You want to deploy this on a bunch of servers, you probably need System Center or some other more complex automation tool. You still had to build things. We were using SourceSafe 15 years ago before Git. We were using Team Foundation Server, right, and automation to build and test and build up a binary or a DLL that we needed to have in testing, and then to test it on the servers or client protocols, or not protocols, but OSs that we needed. Like, these all things existed before DevOps, but it was largely a human effort. Like, you want to deploy this on a server, on 3 servers? Well, you're probably going to have to log into all 3 servers, right? You're probably going to have to like drag and drop some folders, maybe unzip something that you zipped up that came bundled through a versioning automation tool that might have stored them in a file server. Like, these things all existed before. I think a lot more of it for me, especially in the 2000s, it was very, like, we were excited about PowerShell because it was the one thing that was going to save us from the toil of doing the same thing. That following a Word document with screenshots of, this is how you deploy our apps to production, right? Yeah. So when I talk about this stuff, I think there is a misconception, and it's partly us content creators' fault. I got a new guest on this show every week. We're talking about something new every week. You go to the conferences, it's 100 new projects released at that conference that week. And just because these things exist, they didn't exist yesterday. So what were we doing yesterday? Well, that's probably what we should still be doing. I would say the problem with open source is that you don't, well, in Silicon Valley sometimes, you don't really have to have a way to profit or even a good idea to create an open source project. You don't have to, just a bunch of GitHub's likes does not actually correlate directly to how many people are really using this still today, right? So I think a lot of us, shout out to the Discord server over there above Cristi. We're over 17,000 people now on that server. But those of us that have been doing this sort of what I will call, we're going to label it DevOps, but it's really more than that, right? It's understanding infrastructure. It's understanding how do I package, test, and deploy my application. It's understanding how do I manage that production infrastructure. How do I manage developer environments for my team, and how do I make sure they can get all the tooling they need to develop and to run tests locally or to build it locally or whatever. You and I before the show, we were talking about parallels on ARM and like all these well, that's, if you're a small team, these are all the same concerns, right? Like they're all the same. The team has to solve all these problems. And I think the real challenge is that we're just expecting all these tools, like we're expecting that we need to implement each one of a series of tools, and not everybody needs, the ability to auto build across 5 different architectures. But it's nice, like if we can have that automated. Not everybody needs 24/7 high availability, even though the whole industry makes us all think that every app has to have 5.9 uptime and has to be cached geo-globally all around the world. We got caches and CDNs, and we're optimized, and database queries have to be super fast, even though you're 10,000 miles away from the server.
Not to
But
upset
not everybody
their
needs that.
3 customers.
Yeah. I mean, I do miss sometimes the days of like internal company apps that we ran inside the organization that could actually go down all weekend because no one was in the office, so you could just take it down for the whole weekend to do maintenance. Obviously, not a lot of apps can do that anymore, but I think that the need of a lot of this tooling is these are best practices, but it doesn't mean it's the only practice. So you choose to do Docker, but you've probably learned, you don't have to do Docker on everything. Your entire application doesn't have to be Dockerized. It's just a single tool that you could use to containerize just the front end. Maybe that's the one thing, is instead of maybe the back end or some other part, you just do one part in Docker and that's it. And everything else you leave the same as it is today, and you slowly over time move those things maybe over to something like Docker if you think that's convenient for you. You mentioned some core complaints, so traffic's on your list. Like we're going to talk about traffic. What else? Actually, I have this thing. I brought up a thing. You didn't see this earlier. I didn't actually think about it. But we're gonna get into this. So I have DevOps frustrations. Cristi's DevOps frustrations. Why do we need traffic? And we're saying traffic, specifically web proxy. That's what I'm going to classify there.
I mean, by now I kind of know why, but why traffic?
Yeah, right.
Yeah.
Yeah, and this great question. The first part is, I'm going to break this question apart a little bit. My major pain is that I spend more time learning than working on it. So that is true for every new tool that you will adopt for now until you're dead. So yes, that is a problem. I tell this story once in a while. People say, "How do you get you started at Docker?" It was 2014, and I tried it and hated it and gave it up. Like that was my first try, and I didn't understand conceptually. I thought I was trying to make a Linux OS I didn't understand like what is in here and what isn't. It felt magic. It felt like it was doing fancy things with Linux kernels, and it wasn't. It was actually all very basic. I was making it more fancy and complicated than it really is. It's just a suite of automations that help you isolate your app. And at the time, it felt wonderful and magic, and I didn't understand what a build did. I didn't really understand like the idea of an artifact store and why Docker Hub and other Docker registries are such a wonderful transformative way to deploy artifacts and to store artifacts, whether it's code or something else. And so I gave up on it completely because I couldn't make it work because I was trying to run an entire Linux machine in a container. And it wasn't until like 6 months later that someone gave a very specific example, some blog, maybe Hacker News or something. And I thought, oh, we can use it to speed up our testing. And we were using Node.js. So I knew that I had a test command, and I knew that I wanted it to be able to run that command automatically on each version that I built of the app. And so we just did that one thing. We didn't even run it on Docker on the servers. We just, when we made a commit, we didn't even have it automated. We just manually typed Docker build, and we knew that if we built this Docker file, it would run the tests, the test suite. And if it didn't, all the tests didn't succeed, we knew that the build would fail. So we would just run that locally simply to see if the testing was working. And we had multiple different test things. So we had a bunch of different commands, and we used to just use a shell script. So we just put it in a Docker image for building it. And it wasn't even to run production. We didn't do that for a while because at the time, this was like 2014, 2015 maybe, 2014-ish, we didn't really have Docker running on the cloud. Like the cloud didn't provide a bunch of automated ways to run containers. Now in AWS, you have like, I think we had a show last year. We talked about 30 different ways you can run containers in AWS. The first 17 are really easy because they actually have product names, and then after that it gets a little weird. But there's a lot of ways. Like container is now the standard way to run a server workload in the cloud in particular. But other than traffic, let's talk about some other things. Like how is testing? You mentioned that you don't do things locally, so it sounds like you can't. So I can't test apps locally. I can't run them locally in this model. I mean, I know you're doing microservices now. You're breaking off parts of a monolith. So
yeah, we are, and I am running some stuff locally, of course. We only managed to get one of the microservices, or APIs we call them, deployed locally and also on a server on a Linux machine live, like on the internet. And that one, my main, I guess maybe this is a prejudice kind of thing, preconception, whatever you want to call it, that because I develop on Windows, and right now I am on a Mac with Parallels. So if we're doing like, let's say, SQL Server, that doesn't run on ARM anyway. So I have to use a different machine. I log onto it, whatever. So I fundamentally, maybe, like I said, this is a wrong opinion that if I do something on Windows with Docker, it's going to be different on Linux. And I have used Linux many years ago, and I'm familiar with the command line, all those things, the shell. But I have this thing, it's like a block in my head, which, I mean, okay, the promise for me of Docker is primarily automation and automated deployment. So that's my goal. That's where I want to get to. We have our repositories on GitHub. We work on them, commits, whatever. Then we hope to get to a point where we say, okay, we may end up with like 10 different applications, right? UI, a couple of APIs and backends, whatever. I'm hoping for the day when I will be able to deploy these things or update them seamlessly, easily, without typing a bunch of stuff, feeling like in a text-based adventure game, just keep typing and you'll get there somewhere. And I know theoretically that is the promise of Docker containerization, DevOps, really, deployments, CI/CD, what do you want to call it? And I'm really would love to get there. Another one of the frustrations is that when you read up online or whatever, everybody's very opinionated in the open source world or in the Docker world. No, this tool is best. No, you need this tool. No, you need this one. Oh, you should do it this way because this is the best that's worked for me. And I'm like, okay, which one is really the best? Maybe I don't need the best. Maybe, like you say, I don't really need the best. I need what works for me, right? How do I know what works for me?
Yeah, the real challenge there, I feel like, is it all feels very overwhelming when you say, I want to, because what you're saying is we are going to shift from monolith to microservice. We are going to shift from Windows to Linux, and we're going to shift from manually or I will pre-container deployment methodology is what I would call that. That's a really complicated way to say not Docker. How you deploy today, and you're shifting to a Docker-centric workflow. So those are three major lifts that you're doing all at the same time. And granted, that is kind of typical, but one of my talks that I used to do, maybe I should pick that back up again. I'm on dog duty today, so the puppy's in the room. Maybe he'll get on screen here a little bit. But he's too busy right now, chewing his bone. Just recognize the fact that you're doing three major cultural and technology shifts. It's not just technology; it is cultural. To think in a team like microservices, or I don't even want to label it microservices, because what exactly is a microservice? Less than a monolith. That's all we're saying here. We're going to break up a single web server or binary that runs with a bunch of DLLs into another programming language or another framework that separates it out into different components. And so let's just assume that for a second, because I don't know your app. You have a front end, you have a back end. Back end's the API, the front end's running some web interface or web solution. Maybe it's a mobile solution. And then you have other things that we tend to sort of label as like workers and sort of batch and automation things that look at queues to process workload. Maybe you need to print PDF reports or ingest images to adjust them. All sorts of different ways that you can use those. And then you have database component backends.
Did you steal my map? Did you steal my?
And then you have data. You have data stores. Yeah. So like you mentioned earlier, I think we talked about Microsoft SQL, Postgres, an alternative. Kyle's in here. It's like, you need Dagger. That's not helping, Kyle.
There you go.
Kyle's going to be on the show, by the way. We're going to talk about Docker Slim and the rebranding of that and what the future is of that. So shout out to Kyle. But so yeah, Cristi, you don't actually need Dagger, not yet. So there is a challenge in tooling where I don't know, I have really a label for this, and this is not, by the way, there's no shame here what Cristi's going through. I went through it. Every team goes through it every decade, because the reality is we're on a pace right now, and I used to tell this story. In the 90s, we were shifting from mainframe to PC. It blew our minds. We had to go from consolidated monolithic computing to distributed computing. Oh, the SQL server and the website might be on separate servers. That was the 90s, and it was a huge shift. That was sort of also the introduction and the idea of mass open source, where we were not just sharing floppies anymore. We were actually going on websites and downloading open source. Things like PHP got invented. Apache web servers got invented. 80s and 90s there, right? Then the 2000s, we shifted to virtualization, which didn't really change the developer role a lot, but it, for us in infrastructure, massively changed the game. Like, we had a whole new abstraction of things we had to manage that we didn't have to care about before. Before, it was just lots of servers, and each one had a purpose, and usually it was a singular purpose. And then it was, now that one server has 100 servers in it. So we had a whole new series of infrastructure tooling that came in the 2000s. Then in the late 2000s and early 2010s, we had the cloud, which now meant you basically had multiple data centers, and you had another set of tooling, and you had to automate the cloud, and because it was a web interface and it wasn't the same Windows server interface that you were used to because it was in a browser. And so right after that, the next level to me after that big shift was actually just containers. And container tooling is, to me now, a lot of people, especially in the future, they may never have to worry about VMs. They won't have to set up VMs like I had to do 15, 20 years ago. They'll have never actually experienced installing their own Linux VM and going through the setup process and the BIOS settings and all that shit. And we just had the cloud. And now I think what we're going to be seeing is DevOps, and in particular, the Docker tooling is very fundamental. And in fact, we're going to look at a little chart here of like the core DevOps concepts. Let me find that little thing. So this is thrown around in my Discord server a lot. It's called the DevOps roadmap. It's on roadmap.sh. They have all sorts of roadmaps. This guide, by the way, is ridiculous. Like, I do not know all these things, and I've been doing DevOps since before it was DevOps. I do not know all this stuff. This is a fraction. Someone,
if you want to scare them away from
right. So they now have, I don't know when this happened, but they have what's called the beginner version, which really is you choose one tooling in a major area and you learn one of those, just one. So if you think, I look at this as like a slot machine. You know, traditional slot machines, of you have like the chair, you have a roller. It's a round dial that's just spinning, and you have like one's a cherry, one's another fruit. There's grapes, whatever, and then there's like a dollar sign that's like the jackpot or whatever. And when you start thinking of this tooling, I think of it as like pick your language, pick your code storage, pick your code automation, pick your code testing, which is more than one probably, pick where your servers are going to be, and pick a infrastructure management tool. And each one of those is a dial. You have to pick one if you want a complete sort of software lifecycle series of tooling. And of course, most developers start with language, right? Like they pick their first language, and that's the hardest. Oh, which language should I learn first? Well, in DevOps, you don't even have to know a language. Most people think you do. I have rarely ever written code to do DevOps. I just have to know YAML and other configuration file formats, right? Shell scripts maybe is the required language of someone who's trying to automate. But that's less and less nowadays as we get to better and better tooling. We don't even have to know shell scripts as much. But you're coming into this as knowing a programming language, the frameworks of your .NET stuff. And what did you do? Like, let's say rewind 5 years ago, 10 years ago even. Once you had your application and you knew it worked, loosely, briefly describe how you would get that into production. Do you remember how you did that?
Well, recently we started using like Jenkins, but before that it was
Right.
manual. It was really manual, and I would use some sync tools like sync back or whatever, because it was all Windows, right?
Right.
And the bigger the application or the country that you had to deploy this for, like it was a big high traffic one, you needed a bigger machine, right? Because monoliths, that's all about them, right? You need a bigger
Yeah.
machine for that. So it was all manual, just upload all the files. Sometimes we would build them on the machine. We would have C compiler, C sharp compiler installed, right? So then we would build it there and then deploy it in IIS. The database again, install SQL Server, blah blah. So it was manual, the whole
Yeah.
thing really.
Yeah.
But as manual and time consuming as it was, I liked the fact that I knew what I was doing at every single step of the way. I knew exactly what I was doing. There was no unpredictables. There was no magic box that suddenly you type a little command and it suddenly comes up with an entire cluster for you, an entire cloud of stuff. Okay, you know what I mean? So that
Mm-hmm.
that it's not an illusion. It was actual control. I knew exactly what was going on. And I may have told you this before, like when I was running this back end server in my office with a mail server before because we were in this country that didn't have internet all the time too. It was dial up, right? So the server
Yeah.
was running as a mail server inside of the company, dialing up, using fetching the mails. I forgot the name of this mail server, S something. I just forget right now.
Mm-hmm.
And anyway, so it got hacked somehow. We moved to a continuous broadband connection, and that server got hacked. And I was literally watching the mail queue sending out spam emails. I
Yeah.
was looking at it. Yeah, and I was helpless to do anything because it was all Linux command line. I didn't know much. And that moment for me was a defining moment when I said, I don't care for Linux at this point because I'm feeling so helpless, so
Right.
frustrated. I could not stop this person, bot, whatever it was, from sending these spam emails out. I couldn't stop them. And to me, that was like traumatic. Okay, come on, I've
Yeah.
recovered. But, so the control, if you don't know what you're doing in this whole ecosystem, yeah,
Yeah.
you need to learn. You need to learn. But
Yeah.
then, in Windows, that is the illusion, the feeling that I have. I know exactly what's going on, and I know exactly what I'm doing. So I'm trying to find that in this
Yeah.
new world.
Well, and the world of, I mean, and largely what we're talking about too is the world of open source, right? That's like these things come together, and the world of open source doesn't always. They're not always projects like a commercial product where you can call someone. You can't usually call someone on open source, right? You can't look at a manual in open source a lot of times because if it does exist, it's only the best, like Docker and Kubernetes. They have great websites wholly dedicated to their documentation, but that's not true of all these tools. And these tools change so rapidly that it is often you can't just rely on blogs or something that's written 5 years ago because it's probably wrong now. And the pace of change is also a big challenge. But I
Yeah.
think like largely open source, and the idea that on Linux largely everything is just a file, right? So whereas in Windows, you usually had to create very specific interactions between tooling, so it was very deliberate, and we knew, well, there's probably a screen to dedicated how these two tools would work together, right? And they probably had a very specific port, and they would talk to each other that way over TCP, or just locally on the machine, they would somehow talk through registry or some sort of socket. But on Linux, because I think there's this sort of nature in open source and Linux in general of because everything's just a file, we don't have to necessarily talk about how one tool necessarily works with all the other tools because we know that they're all at some point just going to manipulate a bunch of files and folders. So we
Yeah.
we when you look at .NET development, there is a certain amount of expecting you to understand how Windows works, like knowing kernel access, what is it, the COM. I'm trying to think of all the Windows libraries they have to deal with. I'm trying to think of some of those, the Win32 libraries and stuff like that. Like those are things that you're expected to know. And one of the challenges of a lot of this open source tooling in the DevOps world is it kind of implies that you know Linux and that you know shells well. And it doesn't write that anywhere. Like none of this is written anywhere in sort of like all these websites. Like don't learn Docker until you've gone and learned the shell and how Linux works, and how to troubleshoot Linux and where logs are in Linux and how to search for things in Linux. Like these are all things that you would, even how do I use the helpline, the dash dash help in Linux, whereas in Windows it's /?, right? Like there's so many fundamental changes, but in Linux, because you don't have maybe that traditional training and you have what I consider to be like this is not a shaming. It's just like there's a gap there that makes it harder to learn other higher level tooling because all that tooling expects that you know the fundamentals. To me, it's the same way as when I try to work with people that are trying to make a web app, but they don't know networking. And to me, distributed computing is all about networking. It's all about understanding packet sizes and Ethernet interfaces and IP subnets and how all this firewalls, and that's how these two things talk. That's how your website talks to your database. And when I have people that don't learn any of that technology and they're only going to learn it when it breaks, very frustrating for them, right? Like it's super frustrating when the website doesn't talk to the back end or the database. You can't connect to the database and you have no other skills to lean back on because you maybe I don't know if this is you, but I don't know your background that much, but like for me, because I had to build it because I'm old, I have a lot of gray, and I had to build all these things from scratch back in the early 90s. I had to go read a book at Barnes and Noble on TCP IP that was like this thick. It was like 800 pages. I had to read that because that was the only way to learn how the networking worked. And I had to actually configure the router because there was no one else at my office that even knew what Cisco was. So I had to like implement the Cisco router, go get a Cisco certification, figure all that stuff out. And a lot of people today, and I'm not necessarily saying that's you, but a lot of people that are coming into this new, they may not have the Linux OS fundamentals. They may not have the TCP IP and distributed computing fundamentals. And they just jump into something like Docker or building a website. And then in the first time that they have a problem, it's like they don't even know where to look, and I don't blame them. Like if you threw me in the middle of this without all the core understanding, I wouldn't understand it either. So that's a challenge. Like if we go look at that model real quick, this basic model of DevOps, it's like learn a programming language, which this one, by the way, could be shell. It doesn't have to be anything. It's more like learning programming concepts, which you have in spades. And then the next one is Linux, and then networking and protocols. Like these are the two key pieces there that I feel like, well, yeah, it's going to be really hard for the higher level stuff like Docker or Git or Terraform or the cloud, GitHub
I feel
Actions,
it's like
Ansible, Nginx. Yeah.
I feel it's like is that the book I was reading from Seth Godin, The Dip. It's like a dip. Although I'm thinking in the Linux world, it's not intentional dip, but it is a dip anyway, where you have to go through it in order to get to the other side. And I suppose once you do that, you get all the basics down, you get through the dip, and you're at the other end. You're like, oh yeah, this all makes sense now, and I can do these things. I know kung
Yeah.
fu.
Yeah, like the valley of despair. I've heard it referred to that way, where you're excited about a tool, but you can't get it to work and you don't know how to fix it. Happens to me more times than I can count, because it's, you get excited and hyped up. The internet's great at hyping things up and making us all think that we need to do the new thing, like Dagger. Kyle's talking about it earlier. Warp Terminal's another tool. But if we jump back a second, one thing that I always try to start onboarding new clients with, and I see all the questions, by the way, in chat. We're going to get to those in a minute. But one, you have to limit the scope of change, which we talked about. You have these three major evolutions that you're doing that don't just affect the tooling you're using, but also the culture, the workflows and processes you use to step through getting all this stuff done. All of that changes, all three of those major evolutions. And so just one of them is hard. Just doing microservices is hard without containers. Containers makes microservices possible. It's really kind of not, I don't see how it's possible to scale to dozens and dozens of microservices if you don't have containers. But I often try to get teams to focus on pain points. When you're looking down the pipe of like a huge amount of change, we're changing not just the language we're using, but the frameworks we're using, the deployment methodology, the OS of the server, all of our tooling in the middle of all of that stuff. It's all got to change. Like, it's all overwhelming. How can you even possibly do that? And so I always try to get teams that say, okay, well, eventually this is our goal. Like, we're going to be that way in years. But for now, what's the biggest pain? And usually teams are focused on, like, it takes too many man hours to do whatever we're doing, or we're deploying, we're updating too slowly and they want to release things faster and we're having, we can't keep up and we don't have the money to hire new people. Or, one of our core issues is uptime is a problem. Things keep failing and we're constantly in reactive mode of trying to get things back up and running without slowing down new things that people are releasing and the developers are developing. So usually that's like one of the core, like we can summarize a lot of our pains into this one large bucket of pain. And I really find a lot of success in going after the pain points first instead of tooling goals or saying we do DevOps, which is like what would you even consider DevOps and not DevOps, and how do you know you're done? Those are all very nebulous concepts. So if we went back to the list there real quick.
Just a quick question about your list there, because
Yeah.
you said that analogy with the slot machine where you have to turn the thing and choose one.
Yeah.
How do you then deal with? Okay, I'm guessing by choosing one, you're making an informed decision somehow. But how do you deal with like thinking maybe I'm missing out? What if I choose the wrong tool and down the line that's going to bite me in the behind because I made the wrong choice with that tool, because it turns out that tool is limited in that particular. I'm not saying we're building such specialized application that we're going to have some edge case where, yeah, that was a bad decision, man. We cannot do this because we chose the bad thing that back then,
Yeah.
See, that's
Well,
naturally comes.
I mean, sometimes, have you ever heard the phrase like swim in your own lane or swim your own race? And to a large extent, the wrong choice is it should be the only wrong choice is the one that makes it more painful for you to do your job. And in DevOps, we love to measure things. So time to deployment, from the time of first commit or final commit, depending on which one you want to measure, to that feature being released into production, the number of outages per year and the time it took to recover from that outage. These are all like, time to deploy. There's all these different acronyms and different ways. And we think about it as like anything that moves us to faster, more frequent deployments, less downtime, easier recovery from failure, even if that means we shipped something that broke it. Now let's undo that change and go back to the last one. Those kind of recovery scenarios, if you can make all of that faster and easier, meaning less human resources to do it, then you are improving your DevOps goals, right? So like the utopia, there is no done in DevOps. It's really a set of ideas, not tooling. Tooling is just an outcome of the ideas. That are you moving towards a faster, more stable, and more secure software lifecycle where the business has a requirement, it implements that as a feature and ships that to the users in a more reliable and faster way than ever before. Like that's typically when you look at the software development teams that are implementing either off-the-shelf software they bought or software they're developing, it's really a business goal, right? So I try to get the teams to talk about pain, because if they're spending, let's say, 1 day a week manually running jobs to like manually test things or manually update things or manually do any sort of, we call it toil, the thing that you do over and over and over again. We try to figure out what things you're spending all your time on that you don't want to spend your time on. And that usually gets us pretty focused on what's really important to the business right now. I have been on Docker projects where we actually backed out of Docker because they had other bigger problems that were going to, that we needed to implement that first because it was going to be a bigger bang for the buck for the company. Not just it helps this one person automate their deployments, but it was like, well, we're actually on like Rackspace legacy hosting, and we're spending a lot of time managing VMs. This is an example scenario. We're spending a lot of time managing VMs, updating Linux, upgrading Linux servers, rebooting, doing all these manual things. So one of my first things is, well, if you're spending all your time doing that, let's get you on a modern cloud where you never have to touch a shell. Like if you log into a shell on a server nowadays, to me, you're legacy, because there are so many cloud services to help run all this stuff without you ever needing to shell into a VM, or SSH into a VM. To me, that was the 2010s of the cloud. The 2020s of the cloud is we're providing you higher level services. And so like with a container, for example, every one of the three big clouds can take a container image that you've set up properly, and they can run it without you ever having to provision a manual server or do a security update of the server or anything. You would never have a shell into that server. In fact, in a lot of ways, you can't usually get into these servers. And all of them have at least a dozen services that take a container image and do that. So one of my first challenges with teams is, especially small teams like yours, is, okay, we never shell into a server on the internet. And if you're in a data center and you have to still be in the data center, then let's minimize the amount of manual OS work we have to do, right? Which usually means only a few very big machines, not using virtualization and using more containers, because then you can splice up the server. But we really try to focus on that. So from your point of view, if you're looking at those three things, like why do we need, you're sort of listing your DevOps frustrations here, or at least I'm listing them for you. Do you feel like that's really where your pain points lie as a team is, like right now you're tactical on like, why do we need a web proxy? But local testing sounds like it's either hard or not possible. And to me, that is a big red flag, because it means that the whole solution is brittle and not flexible enough to be able to run on this server or that server or in CI or on my local machine. A whole part of the industry is dedicated to making all that super easy. So the harder it is for someone to actually go from scratch to running this thing, and if they can't run it locally and they need some special other team to help them even set it up, that's a big red flag, because you can't easily spin up new CI solutions. You can't easily test GitHub Actions versus Jenkins, or test an ARM machine versus an Intel machine, or test Linux versus Windows. If you just can't even do this stuff because it's so complicated. And I've also been on projects that do that, where we're like, let's just containerize the database purely for testing, which means you're going to have to move Microsoft SQL to Linux Microsoft SQL, not Windows versions of containers or whatever. So sometimes we have to back out, like I'm saying. We have to just back out of containers because the team needs to evolve in other ways before we can even attempt like full container workflows. It's a really long soapbox.
Yeah, well, the local testing question there, I do that, but I don't do it as much as I should, probably because I don't trust it. And trusting in terms of, is it going to work the same way when I actually try to deploy? This is because I hear a lot of people saying...
It's the whole point of Docker. One of the key foundations of Docker is runs everywhere. The same.
Okay, then why do people say, who've done this for years, oh, don't deploy Docker on Windows in production, maybe, because it's not good, it's not stable, it's not whatever. What is the main... Here's one of the questions I came with today.
That's a great question.
Why is such a big difference between these two? If Docker is so universal, ubiquitous, whatever you want to call it, um, why why not why I have several Windows servers available to do all this. Well,
Yeah.
yet here I am trying to learn Linux because people are telling me don't deploy on Windows.
Right. Well, okay, so Docker is not a kernel, right? So it can't run a Linux binary on a Windows kernel. It's not a VM. All it's doing is isolating an application and its files in a part of that existing operating system so that everything that runs in there can't see anything else on the system. But other than that, it is in no way similar to a VM. So if you have a Windows binary, like if you built a .NET CLI or a .NET web tool that is an exe, it has to run on a Windows kernel, which means it has to run on a Windows server because you're not going to run desktops in production, right? So like we all know that. So you're going to have to run a Windows server, which means you are not using Linux containers in any way. Docker supports both Linux containers and Windows containers, but Linux containers are Linux built binaries that have to run on a Linux kernel. So you would have to install the Docker engine. That's the service, the Docker service that runs in the background. That is installed on either a Linux OS, Linux kernel, or a Windows kernel. But the thing that you run in it can't be the same thing because you can't fundamentally run a Linux binary on a Windows kernel and vice versa. So when you start that's why I was saying like it seems like there's a lot of magic to Docker, but it's not. Like Windows has had this actually. There was this thing called, they bought a company called App. I can't remember it anymore, but it was an app isolation technology that would create a virtual registry and a virtual file system and then run an app inside it. And then you would be able to get out. And it was something it was called like VApp or app something. Someone in here to be like old Windows sysadmin. But we did that in the late 2000s. I actually bought companies to do that because like you'd maybe want to run multiple versions of Office on your Windows computer, like old Office 2007 and new Office 2010. And they had this app virtualization technology. And that was the idea. Fundamentally, it was a similar idea to what Docker is. It's not trying to make a new kernel. It is simply creating a new file system area and a new processing area where that process can't see the other ones running on the machine. It doesn't have root. It can't see outside of that little pocket. And we've had this in Linux and Windows and Solaris forever. We got something called jails, something called chroot in Linux, zones in Solaris back in the 90s. These are all the same ideas of coming from mainframe of let's give a little slice of processing and file system to this app, and it can't get to anything else by default. And so in your case, one of your core decisions is, are we trying to run this in a Windows container or in a Linux container? Window containers are only, I'd say, maybe 1% of the entire ecosystem. So just like you might, like when you find any particular tool and it's used in this weird, I can make this tool run in this way, but no one else is doing it kind of scenario. So Windows containers are often discouraged simply because Windows just generally has a harder time doing things from the CLI. And in order to build a container, you have to put everything in it through a CLI. So often if you write a Docker file for a Windows container, you've got PowerShell commands in it, you've got cmd.exe commands in it, right? You're using some sort of command line or scripting language inside that Docker file. But that looks completely different than doing the same .NET things on a bash shell, which is what a Linux container Docker file would look like. It runs shell commands, so then you would run, net build. I can't even remember the .NET space build or whatever the builder command is, right? And so you would use the Linux version of that in a Linux container Docker file. And It is possible to go, like you can run an Nginx web server or a MySQL, maybe not MySQL, but there's a couple of them. Python is another one. And if you download the container on Windows containers in Windows, it will run python.exe because that's a binary built for the Windows kernel. But if you were to do the same, you could run that same command, Docker run Python or whatever, on Linux, but Docker in the background goes, oh, I'm on a Linux OS and I'm running ARM architecture or Intel architecture, because that's the two things it has to care about. Which kernel OS am I using and which architecture am I running for? and it goes and automatically looks for the right image for that binary for that particular system it's running on. So in the background, if you were to run Windows containers, you'd still probably do a Docker run Nginx or Docker run Python or whatever. But in the background, it's downloading a completely different image for Windows kernel running python.exe or whatever.
Follow-up question then.
Yeah.
Are you saying that beyond that decision and that point, everything else is the same? Because it sounds to me like all that stuff explained, it doesn't really make sense to test stuff on Windows, to run it on Windows, if things are so different. And in production, I will end up doing Linux anyway. Maybe I'm missing.
Exactly. So yeah, on Windows desktop today, if you are saying, like, let's just say, I'm going to imagine your scenario for a bit because I don't know all the details, right? We haven't had a chance to have the thorough, 2-hour deep dive into your architecture. But let's say you're going to leave the monolith on Windows where it was always running, and you probably will have to keep changing that and keep redeploying it the old way. However you're deploying it to Windows today with no Windows containers, just keep doing the monolith the way it is. This is a choice, by the way. You don't have to do this. This is just, let's not try to boil the ocean. That's another term I hear a lot of times. Let's not try to solve all these problems all at the same time. We're either going to either containerize the old monolith, or we're going to leave it as is and start creating microservices in Linux as the new paradigm. I see teams doing that a lot, where they say, let's leave the old thing as it is. That process works. Yes, we know that it's not perfect. It's not using all the new shit. Totally fine. We're just going to keep it there. We're going to keep pulling off little features of it, little chunks of it, making into microservices. We might choose different languages based on different team members. One's like, I like Go. Yeah.
That's exactly our plan. Exactly.
So, yeah. So you do that and then put those in Linux containers, run those in Docker desktop locally for testing, run those in production on Docker Engine, or I will argue, let's avoid the server altogether and just figure out a cloud service that will just run you a container. Google Cloud Run, AWS App Runner, every major cloud has these ways that you just run containers, and all you do is you're pointing it to where the container lives in a registry. And after that, it's largely just enabling some automations, and you never have to shell in, you never have to update Docker Engine. You just use the cloud tooling that they provide you. And yes, that is cloud specific. If you changed from AWS to Google, you would have to change that tooling because it's a very specific service. But I think there's a lot of hype on the internet around the idea that everything you're doing is open source and can be moved between clouds freely without friction. Whatever. No. No production team I ever work with has ever done that, where they're simply just using the cloud for raw compute, and it's completely agnostic, and in no way are they using any tooling from that cloud provider. I just want VMs and SSH, and why? That just sounds very painful to me. If I'm going to pick a cloud, I'm going in all in that cloud. Very, very few companies, I think, have the ability to be truly cloud agnostic and live this hybrid life of, I've got half my app over here and over in Google and over in AWS and everything's automated. No, that's an insane amount of complexity. So don't even try that.
Just crazy. Must be crazy.
So yeah, it's stupid complex. And so if you can run Docker desktop locally and take that microservice and get it into a Docker file that can build locally, so I can do a Docker build on your machine, and the rest of the Windows app that it's going to talk to is on a server in your data center or on another machine in your computer. So something else, right? Something outside of your machine, because it's got to be on Windows. And then your database is running somewhere else, even for just testing and whatnot. If you were to build that locally and do a Docker build, get that image, and then get a compose file with all the right port settings and volumes if you need them, probably maybe you don't. And that way, because Docker Compose is really just automating Docker, that's all it's really doing, is saving you all the keystrokes of typing a bunch of Docker run commands, Docker network create, Docker volume create. It saves you all those different commands and just puts it in a single YAML file. So you can just do Docker Compose up. So 100% of the teams I work with use Docker Compose, 100%. If they're using Docker, they're using Compose, because that is meant as the developer's tool for automating local Docker usage. It's not that you can't use it in production. It's just not. Compose is not a multi-server tool designed for orchestration or cloud management, anything like that. So once you can do that and you feel comfortable, then you will start to realize, oh, well, if I want to add a proxy, because in the production servers, I have a load balancer in my cloud that's acting like a proxy and acting as my SSL termination endpoint. That's a load balancer. And a web proxy like Traffic or an Nginx, they all do the same functionality. They all have that same core web proxy, web TLS endpoints, because when you typically need to run 5 different apps, web apps, on the same IP address. Like if you have one server and you want to run a bunch of different things, they're all probably HTTP related, or half of them, let's say, are HTTP driven, and you only have one IP on the server. So a proxy is just necessary in order to have one IP address answer for many websites, many web endpoints. So that's why most of us have ended up with something like Traffic or Nginx or something called Contour. There's a dozen different options at least, and they all have varying levels of complexity and feature sets. And some will cache, some won't. Some will actually run a website. Some are just a proxy. Like they all have varying levels of functionality, but it's not required. You don't have to do a proxy. If it's your day one Docker, you can put the certificate on the hard drive and map it into the container with something called a bind mount and run the app the way you're used to with the certificate in the app itself so that it can respond to HTTPS. And a lot of people don't want to talk about that because that's not like the cloud native utopia way. But again, you can't solve every problem all at the same time. Like you shouldn't have to learn a dozen tools all at the same time. So you just know that, okay, today we're going to get the app into Docker in production for this one microservice. And so a team I'll work with, that'll be the very first goal. And in order to get that goal, that means we have to know how to use Docker files, and how to build the app, how to at least run some tests on the app while it's in a container. And during that process, the whole team is learning. They're learning Docker a little bit. They're learning the mindset of, okay, if we're going to test it in the container, we've got to maybe put some of the testing tooling in the container with it. How do we do that? Like we just sort of evolve our learning over time. And then at some point there's like, hey, look, we can build this thing in a Docker image. We can run it locally against the Windows server remotely and the database remotely, but we can at least run that part of the app on our machine. So let's go see if we can run it on a server. And then you try to do a Docker run or a Docker compose up on a server. And that works. And holy crap. And I've seen companies take that to production. And they're like, that's great. We got it. We just know we SSH in the server. We do a git clone or git pull. And then we do, they think of that way. And then we go, okay, let's don't put the code on the server. We don't want git on the server. Let's just do a Docker run from an image. And they're like, oh, I got to use a Docker hub or some other container registry. So it's an evolution. And I feel like for you, the challenge, I think, I'm just going to guess, is you need some sort of like, well, what do I do first? Because it feels like I've got to do it all at the same time. So how do we slice this thing up and solve one problem at a time, knowing that eventually we will be DevOps utopia? Does that sound like maybe part of your challenge? Like part of the...
Yes. Yeah. We, doing all this learning, like I said, I find that people tell you, or you read online or whatever, the advice on videos and tutorials and courses. You need this for this. You need this for this. But I think everybody's talking from an ideal situation point of view, more or less. And then you feel like if you don't have all these things, you haven't accomplished anything because you're still not there. You don't have your thing deployed, right? And honestly, that is a bit of a nightmare to me. I have actually two things that keep me up at night, and one of them is future-proofing our entire platform, right? So I know it's a monolith. I know monoliths are dying, or it's kind of big. The technology it's built on, it's going to be deprecated soon. We're going to be unable to install it or run it even on newer Windows systems or whatever, right? So that is actually what's driving us to do this in the first place. Because I didn't wake up one morning and felt like, oh yeah, I should probably scrap everything and learn again and learn something completely different. I haven't touched it ever. And because I have nothing else to do, right? No, it's future-proofing. And secondly, I thought, okay, since we're future-proofing this, we might as well deal with other issues that we had in the past. And you touched on them: performance, scalability. The database is a single database. It's very slow. All those things, right?
Yeah.
So that is one thing that's driving us. And then the second thing is really just because you said, okay, what's the pain or the worry is security. And security is on my mind also because it doesn't help if you deploy all these things. You get them all running and everything's sweet. You may get to a point where you say, "Hey, everything's in Docker, everything's running there." But then, if I don't become a security expert overnight, I'm gonna have a catastrophe on my hands when something does go wrong. Okay,
Yeah.
so I know that yeah, like you said, just pick a tool, go with it, and add them as you go. And at some point, we're going to be able to, we're crawling, and then we're going to be walking, and then we're going to be flying. But
Right. Right.
and then we're
Yeah.
hopefully not crashing.
Unfortunately, it doesn't. I mean, because what we're really talking about here, your tooling. So, excuse me. Sorry. The challenge here is like there is a culture of tech, right? There is popular, there's unpopular, there's what's cool, there's what's not cool. There's what works, and then there's technologies that are too early, right? Like where it's edge, bleeding
Cutting
edge,
edge.
maybe too early. But if you think of this all as like the sort of the bell curve of technology adoption, one of the big challenges that like it's been sort of a writing on the wall for over a decade that .NET framework was not the most flexible cloud friendly solution, right? Like the lack of Windows first like top tier Windows servers with top tier IIS .NET framework functionality. Like there are bespoke little tools and maybe even specific clouds that do that, but when it was pretty evident last decade that like Linux was winning the cloud, open source programming languages were winning, um, it a lot of us that were like, well, okay, well, we'll keep watching, right? And then the late 2010s, and it was like, okay, like this is really taken off. It is how every startup starts, right? Look at Silicon Valley, look at where all the money's being spent. None of those people are doing .NET framework apps, right? So where the money goes is sort of where the trends of the future. So if we even look back 20, 30 years and look at those trends, it's like um, the ideas and the paradigm shifts are happening first in the startup community, in the big tech companies where they're all moving everything, and it never really felt to me like .NET framework was getting adopted by more of the ecosystem. It always still felt like a very Microsoft server, Windows server focused thing. So one of the challenges I think you're facing is if someone in the team isn't trying to keep up with these trends and understanding how it's going to shift the landscape over time, you end up having to do 10 years of catch up or 15 years of catch up. And that's what I find to be very common of maybe my Java and .NET framework friends, and I have a lot of those. I live in a military complex of government and military in the United States, and I have 12 military bases within a quick little distance of my house. Like we have tons of government and agencies and stuff like that here, and they all use .NET and Java. Like that is their bread and butter. So the meetups here are huge. Like our .NET meetup is our longest running meetup, going almost 20 years. And the challenge there is that the trends are happening slowly over time, and it only becomes obvious when to some teams when either they're trying to hire new people and the young people aren't learning these languages or frameworks anymore. That's one indicator. Or another indicator is we can't seem to use all the top tier tooling that everyone's telling us to use because we have this particular framework or programming language or deployment model or server OS, whatever piece of the technology is. When it starts to become harder and harder to use, that's to me like a red flag that I sort of pick up on. And it is hard. Like you are in probably one of the hardest transitions I feel like in tech, which is it's not just you're shifting from I'm doing an OS to a VM, or I'm doing VM, but now I'm doing cloud. Like you could have actually done those transitions without completely changing culture. But a lot of this new wave of tooling has really come out of the DevOps culture, which is a transformative shift, kind of like the agile mindset going from waterfall. And it means that people have to think a different way. They have to approach problems differently, because if you have to read a Word document and click on some things, how can I automate that, right? And so like one of the core uses nowadays is like the way an engineer presents value is automating things so that they don't have to do it anymore, which wasn't the case 20 years ago, right? 15 years ago. And so we have this huge shift. So usually when people come to me when they're having a real hard time with this shift, I get them to read the DevOps handbook. And maybe even the same authors had something called the Unicorn Project and the Phoenix Project. And those are like novels, and the DevOps handbook is like a manual to the mindset shift that has to happen so that you don't end up with different tooling, but the same core problems, right? We're not agile. We can't run this thing everywhere. It can only run in this very specific server in this very specific place because that's the only way we know how to make it work. Like those were the problems that we had 15 years ago, but now we know infrastructure is ephemeral. Like the server you have today will be gone soon, right? Like they'll phase it out. They're going to replace it. They're going to need to update the OS. So you can't run on any one server. You have to be agnostic about how many servers you run, where those servers are located. Like you have, of course, requirements, but you can't just be like, well, we only work on Windows Server 2010 because that's the one OS we've certified with. That's kind of the old mindset, and I think that's one of the real cultural shifts that you have to make as well as the tooling shift, which is why I think what for you one of the reasons it feels so hard is because you're trying to take tooling to the old.
Yeah. I'm not resisting the change, and I'm all for new tech and learning stuff and rebranding myself and whatever, revolutionizing my workflow and everything. So I think my main problem why we didn't update 10 years ago, 15 years ago, it's because I was the sole developer and maintainer and deployer and security specialist, database manager, everything. So in this particular context, I was like, man, thousands and thousands of line of code. Why, can I afford to just pause everything and now start deploying, moving stuff away, rewriting stuff? Okay. You can't afford that when that's all you've got, just yourself. And we kind of kept adding features, kept adding modules, different, until the application is massive and it does everything we want. But now we get to the point where, we realize we're going to probably have to lose it, shut it down at some point. Not because the code is bad, C#, but because the thing that is running on, the architecture is built on, is going to die. And even now, I'm installing Visual Studio and it doesn't come with those .NET framework. You have to explicitly go and turn them on. So that's how you know it's the eyes at the door already.
Yeah, and to be fair, like not to pick because we're not picking on .NET. Every other language has this same fundamental problem of like I worked with a team that was on Ruby, and they were on essentially a 15-year-old version of Ruby, and to jump multiple major versions to be current was, I mean, they had to hire an entire different team to do the migration because you couldn't go straight from that old major version to 2 or 3 major versions later. You had to sort of upgrade your code and then upgrade it again. Like there was levels to it. And that is true of any technology. If I walk into a company and I was a server admin and they were running Windows Server 2003, which was something that lasted way too long because it was so good at just being stable and it just ran, so no one touched it. And then you're like, well, now the most current version is Windows Server 2020, and we now have to jump 5 different versions. That's a huge lift. Like you probably can't even migrate your app once. You have to do it multiple times, and that is a near insurmountable problem for a single person. And in fact, that's why I actually bought the domain Solo DevOps. Did nothing with it so far. But the idea was if there's one developer or one person, maybe even not a developer, that's responsible for what we now call DevOps, which really means everything after code commit. Because, the word has been turned into this meaningless, nebulous, what does it even mean? Because everyone labels their shit as DevOps. So we never had to worry about that because originally it was one server, you SSH'd into it or a remote desktoped into a Windows server. You did everything on that server, and as long as you knew that one server and your app, you were fine. But it's just not the reality anymore. And the sad part is playing catch up sucks in any part of technology because you might focus on DevOps today, and then .NET Core, before you know it, or just .NET now, has 2 major version releases, and you're like, I can't even I want to do this new RRM version, but I can't because it doesn't support the new .NET version, and now I've got to upgrade my .NET 3 different versions, and you're like, you have to spend the next 6 months learning .NET, which means you're now out of date with what the cloud is doing, and there's all these new releases. So just realize that all of us are in a perpetual state of we don't know, and it takes a community. So like step 1, find friends, find a community that you can find for trusted answers, like myself. And because I don't know everything. If I'm struggling with like what's the right programming languages for me to focus on right now, if I'm going to be on the leading edge, like I have to go learn from other people on that. Or what's the next thing after GitOps, because I learned GitOps, but only after it had been out for 3 years or 2 years before I even started looking at it. And maybe there's something new, but I don't know because I haven't checked. So even as someone who teaches this for a living, there's no way for me to be the most current. I have to be at least versions out of date on something. And so it's just a natural state. And it's a pure, like, if it's one of those things where like, if you don't find happiness and zenness and just realizing that a good portion of your infrastructure or code or something in your whole solution is inefficient and not ideal, and when you're not proud of it and willing to put it up on the internet, like you're always going to be in that state for the rest of your life. And if you can't find like some sort of meditative state to be okay with that, maybe it's not the right job. I'm not saying for you, I'm just saying for other people, like you've got to be able to stay okay with, yeah, I know that I've got a .NET app that's like 4 major versions out of date. Like it's probably 7 years old, but I still use it as an example app because it still works.
Yeah,
so
it works.
Yeah, I guess maybe that's an argument for Docker, is that if you can get it into .NET Core on Linux, then you can run that version. You will be able to run that version most likely, almost certainly, which I'm not trying to think of a scenario that's not true. You can still run that version a decade from now, because one of the biggest problems is libraries and things move and evolve, and a lot of times, especially on the Windows side, you have to wait for that company to release it, or you have to buy an upgrade because it's a paid product or whatever for that, and you don't have the money for that. But in Docker, for example, like in my course, I have .NET 6 apps. You know how old .NET 6? I think .NET 6 is at least a decade old, but it still runs great in Docker because that image version, even though it's horribly insecure and has tons of vulnerabilities in it, I can still run that locally if I need to. Because on Windows side, it would be like, well, you've got to get the old Windows server out, because in order to run that version of the DLL, you have to run this .NET version, and that version only works on this version of the Windows OS. And that's just the good news for you is on the Linux side, we don't have that tight coupling anymore. So it's rare. It's super, super rare that there's like a Linux kernel feature that makes your app break. And it's like you have to run that old version of Linux in order to get your app to work right. Like that's just not the case anymore. It's usually I need those old dependencies. And on Linux, because we have enough of this ecosystem built out enough, you can usually find a way to build that Docker image, and then you forever have that artifact with those versions of dependencies forever and ever, and you keep it, which is why we love these artifact stores like Docker Hub, because it keeps that shit around. You can keep it forever. And so a lot of my old apps and my examples for my courses still work great because of Docker, like, not in spite of it, right? So you don't think that you're going to have to like keep up to date on everything and everywhere in Docker forever and ever. You could still run a 6-year-old version of Docker on a new OS today, and you could still run the new Docker version on probably a 4-year-old, 6-year-old version of Linux. It all kind of tends to work out in the end with that, and it'll help you. Yeah. All right, I know we've been going long. Do you have any other questions? I'm happy to answer more.
Well, I mean, without getting into super detailed stuff, I don't think so. I think I've got all my big ones out, big questions, kind of strategy ones. Like I don't want to get into what's the difference between this and that and what the other. So I can probably find that out.
Yeah, well, I mean, like if we've got if let's say we have a few more minutes to kill, like throw some of those rapid fires at me, and let's see if we can knock them out. We'll make some clips. I'll get my editor to make some clips.
Questions from the audience, maybe? I don't know if anybody's
Yeah,
asking still.
we had a few earlier. Unsecure had to leave, but Baba was joking about I still paranoid about hooking up my credit card to AWS. Yeah, my credit card has been in AWS for 15 years, and the only issue I ever had was when I accidentally left on a whole bunch of servers, and because I was doing a demo. Well, because I teach curriculum, and I actually went to a conference and taught a bunch of people, and then I left, and I was in a hurry to get on a plane, and I forgot to turn off like 200 servers. So 3 days later, I thought about it. I was like, I don't think I turned those off when I got back home after the flight, and I realized I had like a $5,000 bill from like 3 days or whatever on my personal credit card. And Amazon was so gracious, which they have a history of doing this. They just removed that. I explained it to them. I said this was a total mix-up, a mistake, and they said, "Yeah, we'll forgive you that scenario." So. Now, to be fair, I wasn't Bitcoin mining that whole time, so it wasn't like I was killing all their infrastructure accidentally. But that credit card, yeah, it's fine. Yeah, you're fine.
Here's a question for you, if nothing else. One that I actually found today was we were running this Docker container with our little application, and it was running, it was connecting to the database, and all that stuff was working fine. But then, but it was not able to, initially it wasn't able to connect to the database. The database was running on the same machine, local host, whatever. And then the Docker container couldn't connect to it. So we were like, oh, the error from Postgres was that this user didn't have, permissions or whatever. So I knew the password was right, that the host, everything was correct.
Oh, so so Postgres was seeing the connection attempt. You were seeing that in the Postgres logs.
Yeah. So then it was like, oh, this is not allowed for some reason. And the IP address of the Docker container or application was some weird random 172 something, which why does it create? So I thought, does it create its own IPs for everything it runs? And then this Postgres, which was running on the machine itself, was like, I can't let this thing connect to me. Yeah, it was weird. I was like, I thought everything was local. What?
I highly recommend you take the course Docker Mastery from this guy that I know that creates a 21-hour course. But the first like 5 hours is really all the core concepts. Docker networking. So Docker networking is the thing. So your container is in this confined little imaginary object, right? We call that a container, and that is like a jail, so that anything in it can't see other processes, can't see other files outside of that container. But the other thing it gets, besides its own file system, its own process namespace, is it also gets a virtual interface on a virtual network, so that it has its own IP separate from all the other containers. And that's by default. Now, all of these things are changeable. You can, by default, a Docker container runs in a Docker network, which is not the same thing as your host IP address, your host Ethernet NIC. So when you're in a container, localhost to the container is that container. So if you were in a container, like if you're running Drupal or some other, WordPress or something like that, and you're running it in a container, and you have Postgres running in a separate container on the same server, those two things have different IP addresses. To each one of them, the local host is only that container. And in order for the web server, whatever app, to talk to the database, it has to know the name of that database container on the network. Because they're crossing over.
The name, not the IP address or whatnot, which can change.
Right. In the world of containers, you should never be looking at IP addresses. I mean, unless you're trying to troubleshoot and try to figure out something like DNS resolution or something else. Everything gets a name. Every container you create, and my whole course steps you through this step by step by step, learning these concepts of like, what is a Docker network? How do you create multiple Docker networks? How do you run containers on the same Docker network? What does that mean? What does it mean to publish a port instead of expose a port? Because those are two different things in Docker. How do you run on the host networking, which is the physical IP address of the host? You can do all of that. It's all options. But you start with, by default, if you just said Docker run nginx and you typed in that 5 times, you'd have 5 separate containers, each with its own IP address on a different network than the host network. Now they can all still get to the internet or to your physical network because it makes your host IP address act like a router, essentially, like a firewall router. And so all of those containers can get out. But yeah, they're not, unless you do something specific, like you can do something during a Docker run command called -- network equals host. And that will disable the virtual networking of Docker and bind mount that container to the specific, it'll basically mount to the specific network of your IP address of your host and run as if it's a native thing on your host operating system. So you can disable all of that advanced functionality of Docker for the networking, but it's there for a reason. It's there because it allows you to create 5 containers running the same web app, and then they all resolve to the same name, right? On the same IP address with the same port. Like you can do the type of distributed computing stuff only because you can run 5 different web servers on port 80 because they're all designed around port 80, but because they're running on separate IP addresses, they're not conflicting. So there's a lot of advanced functionality, and don't even get into like, if we start talking about Kubernetes and some of the complexity there, you really need you need to have a certification in networking at that point, because you're acting like, when you're doing all this stuff, you're acting like a network engineer, where you're opening up ports in the firewall and specifically setting up subnets and all that kind of stuff. Like these products are meant to solve that, because in the end of the day, when you start running Docker, you have a single server and you want to run a bunch of different apps on that server in their own containers, individual containers, but they shouldn't conflict with each other. And the only way they're really going to be able to do that is if they all get their own dedicated IP. Otherwise, you could only run one Nginx on port 80, right? And then that would be the same problem you have with your old apps before containers, which meant if you ran Apache on a regular Linux server or an IIS server on Windows, IIS can only run one website on port 80, unless you start doing DNS fancy things, right? So one of the problems that Docker wanted to solve is, can you run 100 websites all on the same machine without any of them conflicting with each other? And yes, you totally can. But it means that now you have things like new abstractions of Docker networking that you have to deal with. So it's a great question, by the way.
Makes sense.
Yeah.
Thank you.
Kuzner, what's up? Just finished your Udemy course. You're welcome. Thank you so much for taking the course. And
now you know everything. Yes.
Yeah. Now at least you know the basics, the beginnings. Yeah. I mean, we had comments earlier about the rift between Windows and Linux. We had comments about automation. I think you asked about like GitHub. Any questions there about like using GitHub, or like you said? I think you said you were using a pull request workflow for.
Yes. We use that. We have several repositories for the different applications, as we are now starting to break it up, like you described. We are taking this exact approach that you described. We're going to keep the monolith going, of course, but slowly ripping bits apart from it while we continue to run it. But then those bits will move to their own dedicated microservices. And we will stay with .NET because this is our language of choice. We love it.
Sure.
We can code in it. It's not, I mean, I'm not going to go starting Python all of a sudden for some reason. Okay, no problem with Python. We just have zero experience with it, right? Which is
another shift. Yeah, you wouldn't want to change languages for no reasons. You would need a business decision to change languages. Now, .NET, I mean, C# is still a very popular language. It's not like that language is going away. They were just deprecating an old framework model. So, I would fully support a team that came to me and said, "Hey, we're all C# developers. Should we keep doing that for the future?" I'm like, absolutely. Get on the latest .NET, run it on Linux. You'll be rocking. And obviously, Microsoft's putting all their money behind that. So, and framework lasted for 20 years. So, framework was a great idea. It lasted for 20 years.
We don't need to reinvent everything from scratch. And a lot of the code, actually, I think, because I'm thinking about the code itself, is going to be copy paste, really, because we don't do any fancy, it's e-commerce stuff, right?
Yeah.
Shopping carts and customer
The business
logins
logic
and
is probably very much
yeah,
the same, right? Yeah.
absolutely. And I pretty much have, because I know one of the challenges in microservices is breaking things down into domain based, right? So you're doing that. Um, a lot of people say that's actually a big issue when you do that, because you don't know what to break and where to put it.
Yeah.
But I have that very clear in my mind, because we know exactly what the separation is for each of the domains, as it were.
Yeah.
So honestly, I think we might probably end up with possibly just like 10 different applications, 10 applications,
Yeah.
which I know is not a lot. Maybe it's a lot for some people. Uh,
Yeah.
so
Yeah. It's not I mean, it's not a lot. I mean, we don't really have like middle services is what I want to call it. Like not monolith, not micro, just middle, like average services. Like we use this term microservices to mean a lot of different things. It really just means breaking up your app into separate parts. But I always encourage the teams that I've worked with. I have seen people start microservices, back out. I've seen people go to microservices and go back to like not monoliths, but like it seems to be that there is this very happy middle area, which is not a religion. It is not either or absolute, or your thing is too big, it's no longer a microservice. Like just ignore all that hype on the internet and just say only break up what makes sense to you. Don't do it because you think you're supposed to. Just think of it as, does this make sense? And sometimes that's organizational. I worked with teams where the front end team was separate from the API team. So when they were breaking apart their monolith, the big push was, let's just pull the front web interface, which wasn't strictly, it wasn't just a browser. It was also, there was also a little bit of API to their front end that team managed that. So they broke it apart by organization. So that makes sense to a lot of teams, and a lot of those where it's people are taking in consideration of organization and of expertise. Maybe we want to take jobs, like you have maybe some sort of high CPU intensive job process that right now is running in the monolith, and it eats up a lot of the CPU time and has a bunch of threads. And you're like, that makes sense to separate that out because we want to put that on a really big server with lots of CPUs, or we want to be able to scale that out wide through dynamic scaling, where if we get a bunch of requests, we can run 1,000 jobs all at once. And so you have to break that out and put it into its own dynamic grouping on your cloud. Like those are good reasons to separate stuff out. Sometimes I've seen teams where they get a couple of young engineers that know new languages. And so they actually they just really say, well, let's give that team a bone and give them this new feature, and they're going to implement that in a different language. And obviously that can't run in the same container because it's a different language. We don't want to really make that, we want that distinction of like, this binary runs in this one, it has a very clear dependency set, and this other one has a different language, different dependencies, so let's make that a separate container.
yeah.
It just, there's lots of different reasons for splitting it up, but I try not to get too religious because I find that anyone who makes like a hard line, like, well, if it's not this URL in the API, then it's a new microservice. Like when that starts to happen, and it's very rigid like that, it seems to make more work for the team because now you have 1,000 repos. Like you're choosing your problem. Now you're either like, okay, we got 50 repos and it's a lot of work. I got to git pull 50 times. So some people put a bunch of their different little parts all in the same repo, and so they have we call a mono repo, but microservices in a giant mono repo. That works for some teams. Some teams want to separate them out into separate repositories and Git. That's all really fine. I've seen it work and not work in every single one of those scenarios. It just really depends on the team, I think. So it sounds like you've got a good understanding of what your hurdles are. We didn't mention the traffic thing. So your app, you're trying to use traffic are you trying to use it so that you can go to multiple websites or multiple DNS names and multiple containers through a single IP address, or are you trying to do it for TLS purposes, or what's your goals there?
Both. So what we're playing with right now is a single server,
Mm-hmm.
single Linux server, an actual bare metal machine, right? And we are trying to get as many containers as we can on this one
Yeah.
to develop with. This is like a discardable machine just for
Sure.
learning, for testing, development. I don't know. So very cheap as well, but it's got plenty of memory and everything. So I think we can run the whole thing on it, no
Yeah.
problem, no pain. So this is what we're trying to do now: is getting all these applications launched in their own containers, and then using traffic because someone told us it was the right way to do. to use traffic to map domain names or subdomains to these, which are RESTful APIs, most of them. These services, they're mostly RESTful APIs. So we're trying to map subdomains and things to them. And also, I hear traffic takes care of the SSL and all that stuff. So
Hmm.
then that is why we are looking at traffic, to get all that traffic
Yeah.
going into these things so we can run them, talk to
Right.
them.
So is
That's
this
my
more of a single on this server? Um, are you trying to create different developer environments running the same things but for different people? Or are you
no,
really just trying to run one of each so that you can have the whole solution as an example of like, this is how we
exactly,
run it all in Docker on a single server
exactly,
with all the things in containers? Okay. So when you say like
exactly.
20, uh, have you written all 20? Do you have like the basic, like, are all 20 functioning, or did you just start with like
No,
one or two?
we have like three now. I think
Okay.
they're all in different stages of development. One of them is actually kind of done.
Yeah.
It's like an authentication thing that we want to use. We want to put that in first, so that that would be our authentication, logging in, API key manager, tokenizer,
Hmm.
the whole thing, right? Without this, the way that we sort of architectured the whole thing, without it, nothing else is going to be able to talk to each other,
Yeah.
because no logins. And then we have also a UI, which someone is building now from scratch, new complete UI in React. That's going to be its own application already. We have a version of that going. And then we have a couple more in different stages of development, which are not yet ready to deploy here. But once we figure out, this is our thing. And every
Yep.
time, when I started this, I was like, I really need to figure out a blueprint, really, for one of these simple RESTful APIs that owns its data, has its own database, and I can predictably and easily deploy from our repository all the way to a production, as it were, or dev, whatever, testing environment. And I'm saying, yeah, that's the one, that's the way it works. Then we will easily replicate the same, similar, different APIs and different microservices, but kind of the same not infrastructure, the same, platform, as code, same language, same, uh, just in a different container, right? With
Yeah.
different. So that is what I'm actually working towards now. Just getting a blueprint. That's the word for it. You know.
Yeah. Yeah. And I think that's what really, when I'm helping people Dockerize their app for the very first time, so if let's say you had the three, right? You're talking about the three here. And so each one of these, it sounds like you're having a separate repository for, because this is all
Yeah.
kind of related, right? How you structure your Git repos, how you structure the applications talking to each other, how we decide which Docker networks they should run on, how we configure traffic, how you work, how do you test these things in CI? This is all kind of related, and it it seems daunting. So that's why I had the consulting, right? It's because companies would like, we don't even know, like, we're so afraid of doing five things wrong, and then like in a year we still haven't done this thing, that we just want the shortcut. And that's why honestly there's Boxboat and all these crazy, there's tons of container and sort of modern infrastructure consulting companies, because that's what they do, right? They help you shortcut all of this onboarding of this distributed technology, and containers drives a lot of it. So it's not really Docker's fault, because you could do all this stuff before Docker, but not very many people were deploying three different parts of the same app along with a web proxy TLS front end, all in the same server, and then figuring out how they all talk to each other, right? Like that wasn't that common before. So in this case, you have three different repositories, right?
Yeah.
And each one has its own Docker file that builds a Docker image of that app, right?
Yeah.
Okay. So if I were to run all three of these, I would be running three Docker run commands, right? And when I did that, they're all technically living on a Docker network. That's what this blue oval is. It's a single Docker network. They all have an IP address, like 172.18 dot something, right? And they're all there. And if API 3 wants to be able to talk to API 1, it can do so directly without ever leaving the server. It can just talk directly. I can just, if I named these in my Docker runs, if I named them, then API 3 could talk to API 1 just with HTTP://API 1. Like it just literally uses the container name as the host name, and it talks, and Docker manages all the DNS for that because it has built-in DNS resolution management. So, but
Is that
all of
better
this,
than is that better than going via its actual host name and out into the internet and back in? Faster, less
there are maybe a few reasons to do that, but almost always this is the way you want to do it. You don't want API 3 to leave the server and go somewhere else and come back in order to just talk to API 2. It should stay as close as possible. So in this case, none of these are running TLS. They're all running unencrypted HTTP, and they're all talking to each other. This is like super simple, right? We're starting simple. Because companies will come in and say, well, all of our applications talking to each other all have to be able to, everything has to be encrypted end to end. Every endpoint has to talk to every other endpoint through encryption, and that's fine. Like that just adds more requirements and complexity, but it doesn't have to be that way. So it's good to know like this works out of the box. And if I showed you like one of the many examples, right, in the Docker Mastery course. If I just go, let's do compose sample 3. Let's look at this one. So a compose file saves you. This is a very simple one. Let's maybe look at another one with the database in it. This one right here, maybe that's a proxy in the web. I'm going to look for a different one here. Swarm app 2. Assignment moved to Swarm app 1. Let's look at this one. All right, so this right here is a YAML file that defines one container. They call them services in a compose file. But it saves you the time of knowing all of the Docker commands. You don't have to run 3 different Docker run commands as well as a Docker network create command, and you don't have to write a bunch of volume commands if you need to store files and data like a database. You would need to create a Docker volume for that. All that's done with a single YAML file in Compose. So you don't, basically once you're using Docker Compose, you no longer need to know all the Docker run commands because there's a Compose equivalent. There's a Docker Compose run, there's a Docker Compose exec, there's a Docker Compose logs, all the different Docker commands you would have. There's a Compose scenario option for that. So you would type Docker space compose space something. And this is me running Redis in a container, and I give it a bunch of like which network to connect to in my Docker virtual networking. How many copies of this container do I want it to run? Because it can run more than one copy of it. It's called a replica. This is all about restart config. We don't have to worry about that. And then I run the database, and I do things like, here I would set the database password and the database admin account. I would specify the location of the database volume, which is where the database would store its files. And environment variables. This is how I pass environment variables, and you might have dozens of them. And then this is a web app called Vote, and it needs to be on the same network as the front end app so they can be near each other. And I actually have things like depends on, meaning make sure that this other container starts first before I start this one because it's a dependency. So there's all sorts of stuff you learn about here. And the nice thing about this being YAML, and you can go through my course, which teaches you the YAML of Compose, and then looking through the documentation, is I feel like it's a little more discoverable here. Like you might be able to look at this and heck, even Visual Studio Code, VS Code, or any of the other ones will help you write your Compose file. And it will help you, define the ports that it runs on inside the container, and then which port you want Docker to publish on the server. And the term publish is very specific in Docker and Kubernetes. Publish means I'm exposing that port to things on my real physical network with the host's IP address. That's a publish. But in this case, what we're saying is my app itself, this is a .NET app, it runs on 5,000. But when I publish it to server IP address for the internet to use or for other servers in your data center or team, I want it to be seen on port 80. It's a pretty simple app, so it's not running in this case, you would probably run the proxy on port 80 on the host. And then this is the back end of that, and it runs on a different container. So it's like an API. Anyway, so I have simple. You go through these sample apps, you learn how to deploy them and how to configure them and change them and stuff like that in the course. But once going through the exercise of building that file, to me, really helped galvanize the DevOps concerns of your app, which means what ports do I need? What app needs to talk to what app, right? Which networks does it need to be on? Do I need to worry about volume data, meaning data that has to persist when the application is no longer running? You're not running your databases yet in containers, which is fine. You don't have to. But that's what all these concerns are. And you can have multiple networks like this one. It actually creates 2 virtual networks. You can have multiple volumes. This is what's called a bind mount, which is where it takes a file on the host and puts it into the container so that the container, so it's not a copy, it's actually making that file like a shortcut from the host into the container. So if you have something on the host that you need the container to see, you can do that with a bind mount. So yeah, there's a lot to it. It is like learning about everything in a data center all in a single tool, which is why it can be perceived as a little bit of magic. But that's what you would be building here. And so you would make this compose file have all of these, and then eventually you're like, now I need to write, I need now on my server, I need traffic to listen on port 80, right? So this needs to run on 80.443, and it needs to direct traffic to this based on those endpoints. And so this network is technically, you would run this traffic app on the same network. So it would be just another container running on that Docker network. And it would be the only one that would have published ports. So the rest of them would not, they would just run inside the Docker network on their exposed port, which is the one they're listening on. If it's, every framework has a default, right? Like some of them love to use 3,000, some use 55,000. Doesn't really matter because traffic is going to point at each one of those at whatever port they want to run on. And each one of them has a private IP address, including traffic. So technically, traffic has 2 IP addresses in this case. It has the one on the Docker virtual network, and then it has the actual IP address of the host because I've published it. And I have an example that I'll give you that you can actually take home. Bret Fisher. I have an example TLS setup using traffic and compose so that for development, and I only say this is for development because it's ideal. It's designed for the local setup, but it's not far from a true production setup. And in this case, you can use Let's Encrypt, or you can use a self-signed certificate for local, so you don't even have to use TLS. You don't have to even mess with Let's Encrypt. Let's Encrypt is definitely the way to go, so that you don't have to buy and install your own certificates. Let's Encrypt is not new; it's been around a decade. You might already use it, but yeah, this might help you a little bit. I'm gonna put this in chat for everybody in chat. Local TLS dev setup with traffic. But I designed this, and all it is just a simple little script to automate the creation of the actual certificate files, like the regular old CRT files. But the compose file just has like this is a sample web server, and then another sample web server, and then traffic acts as the front end proxy, and you'll notice that it's publishing on the 2 main web ports. And then I actually use this way to get the config in. So
what's 8080 for? Why does it expose that also?
It has a web GUI for management for
okay.
traffic, like traffic stats. You can actually look at the traffic coming in. You can inspect it a little bit, and you don't have to have that. You don't have to turn that on at all. It's actually like if you wouldn't want to put that on the internet anyway. So there are various ways in their documentation where you can sort of expose it through a login or something else. But since this was easy mode for local use, it was just like, hey, just put it up there and no authentication. And it's a read-write interface, so you wouldn't want to put that on the internet anyway, because then someone could change your server without you knowing. But
I
what
see
you're doing,
2.9 there. I know they came out
Yeah.
with version 3 now. Is that kind of be the same? Because we looked at the different files, and I think the YAMLs for that look different. For
slightly.
3.
I haven't tested this with 3.0, but there's nothing wrong with 2. Like, you don't have to go to 3 yet. 2 will work for years to come. I mean, they've been running 2 for 5 years now. So I'm not too worried that this is like not useful because up until a week ago, up until like 3 weeks ago, all we had was 2, right? For the last 5 years. So it's, but there's probably something here. So because traffic is container aware, it knows when I create this container, I give it these labels, and these labels are just metadata on the object, which is the container. And then traffic can talk to the Docker API and ask Docker, hey, what are the labels of all the other containers? And if they have specific labels like this, it gives traffic direction that I'm saying, hey, give it this DNS name so that when the front end proxy receives traffic to that URL, send it to this container. And I do all of my configuration in this, and then there's a very simple traffic YAML file inside this code that there's not much in it. There's not much to it. It's pretty, like it defines a certificate. It hard codes a certificate. So it's not using Let's Encrypt, even though there is options there for that. And then it listens on specific ports. So you have to get, like, if you did Nginx or anything else, you'd have to set up each port you want it to listen on. Does it use TLS? That kind of thing. Do I want to?
Yeah, well, it sounds more. It sounds to me like it's more. It's easier to work with, I guess. And I think one of their selling points is they say they have auto discovery and all those things, which
Yeah. It's container native. It was meant for Docker. So Nginx has been around for 20 years, 30 years maybe, but Nginx is a lot of things. It can cache. It can be like a reverse proxy as well as a forward proxy. So like all the users on your network that want to go and access the internet, you can use it as a cache for them. You can use it to run regular websites, so it can store HTML. And traffic does none of that. It doesn't cache. It doesn't run websites. It just acts as an HTTP proxy. And now it does other protocols, gRPC, some others. But it was primarily at first, it was really just a HTTP, HTTPS front-end proxy so that you can do things like offload TLS so that your apps don't have to have their own certificates. And then the other benefit was just simply DNS routing so that you could have 100 containers all in the same host running 100 websites at 100 different URLs, and then one proxy in front of all that to direct the traffic based on DNS name or any other HTTP header stuff do you want to do there. So
here's my other question that I had, which is a big one that I never, well, a big one. I never, I never got a straight answer for is I know that we're now struggling to get this running on one machine, right? So
yeah,
let's say that we get all of our 10 applications on one machine. Traffic is in front of it. It's going to deal with it. Great, fantastic. But what if let's say we get a bunch of small machines and we decide to break this whole thing into our own little mini cloud? Let's say we
yeah,
want to stay away from AWS because for us it's proven expensive. Yeah, I know why, because the monolith, you need to buy a big, massive EC2 instance that costs an arm and a leg every hour.
yeah,
Okay. But let's say that we say, oh, we're going to break this apart and we need a couple of these guys don't need to run on the same machine. They will be like, let's say, a web crawler, a search engine somewhere else, one of that deals with an analytics data, and it doesn't need to be readily available and fast and no latency locally.
yeah.
Would that means that now we're talking internet-wide kind of domain names, subdomains to talk to these things, obviously, because they can't be called by names anymore, and a traffic for each one, right? Am I saying that correctly?
So that is if you stick with just Docker. Okay, so Docker, the engine, only understands one server, the server it's running on, right? Compose only understands the one server it's running on when you use Docker Compose up, for example, which replaces Docker Run. They concern themselves with a single engine, which we now call the container runtime. So like in .NET, you have the .NET runtime. Containers have a runtime. And in Docker, we consider that Docker. There are other ones. There's one that Docker actually uses underneath. You can actually see the binary running in the background. It's called containerd. There's other ones. One's called Cryo. But anyway, these are low-level tools that when you run the thing like Docker run, these are the things that talk to the Linux kernel and set up the Linux kernel concepts for how do I isolate the file system? How do I give it its own IP address? These are all Linux kernel things. This isn't really what Docker just automates the Linux kernel. It doesn't really implement a brand new set of technologies. The virtual Ethernet interface we call VES, which is not a new thing in Linux. It's been around for decades. And so Docker is automating all that. But the minute you want two machines, you just have a choice. Do I do the same thing I'm doing? I just do it twice, which means I go in this machine 1, and I do Docker run, and then I go in machine 2, and I do Docker run. That's what you would have had to do before, right? Before containers, you would have had to manage each server separately. Or at least when you deploy the application updates, you're deploying them separately. Or you do orchestration, which is Kubernetes and Swarm. Those are the two most popular open source ones. All the clouds have their own proprietary ones, but they take a bunch of machines and make them act like one Docker engine. That's their only purpose. Sorry, I got a lozenge in for my sore throat. That's the only purpose really of orchestration, is make 100 machines act like one, so that the thing I did in Docker, and that's why Docker locally is so important for you. Like if you came to me and your team and you said, what's the first thing we're going to do? I said, we're going to get you a development environment on your machine, running the containers as you did on that server. Like, I would have trashed the server. I'd ignore the server. And I'd say, if you can't run it locally, you can't run it on a server. Like, the server is complicated because now it doesn't have any of your tooling. It doesn't have the source code. It doesn't have any of that stuff. But if you can do it locally in Docker, chances are it'll run the exact same way on the server. So on your machine, you would install Docker Desktop, enable WSL2 specifically, which gives you that Linux VM that's built into Windows, which is better than Mac in some cases for development on Linux. Windows is like the best place to develop because you can develop Linux native and Windows native on there, and you can't do that anywhere else. So Windows is still a great place for Linux containers. I think it is the best place for Linux for Windows containers. Sorry, Linux containers. So when you enable WSL2, you get that new shell. So you have PowerShell, the command prompt, and now a new shell. If it's Ubuntu, it's Bash, and you would run your containers commands in there. You could run them in PowerShell, but you might as well get used to Linux. So I would have your team clone your repos into the Linux VM itself. So they were on that. It just makes things a little easier for file permissions because, like Windows NTFS file permissions are not the same as Linux file permissions. So let's just keep it simple, keep it all in Linux. And then if you're using VS Code, like what's your editors that you and your team use?
Visual Studio is what we use.
Not VS Code.
No. It's because of the .NET framework and building all that and
right.
Web forms. Our application is doing web forms now, web API. We have a bunch of console apps. VS Code, it's kind of, we build stuff in Visual Studio, or we may use the one from JBrain. What was the name?
JetBrains. Yep.
Yeah. I'm having.
Well.
Yeah. So yeah.
What you want to use. Yeah, and what you want to look up, I'm pretty sure that Visual Studio does this, but I haven't checked. Visual Studio, like everything on Windows, is about developing in WSL now. So JetBrains support it, VS Code supports it. I am assuming Visual Studio supports it, where your code lives in the Linux VM. It's running in the background so efficiently that it doesn't really add complexity, or it doesn't eat your CPU like a regular VM would. It's quite optimized. And you can even share files back and forth. It all works wonderfully from the file system in Windows and the file system in Linux. But if you put everything in Linux, it becomes easier because now the commands you type the exact same way, and I don't mean just Docker commands, because Docker commands are the same regardless of what OS. But like if you want to ping something or curl something, all those commands are the same in Linux as they would be on your servers. So you get the benefit of learning a little bit of Linux, cloning all your stuff with Git, and then your editor jumps into that different environment and acts natively so that you can edit locally on your Windows host, because you don't want to change your way you develop. Like you still want to use your developing IDE. It just happens to not be using the file system on your Windows machine, but the file system in the Linux VM. And when you do that, you actually get a big performance boost. You don't have to worry about permissions problems as much. And so my teams, once I get them used to that, they're like, man, WSL2 is awesome. I love it. And they just start using that. They use the new Windows terminal to access things. And then with Docker Desktop installed, you get a GUI with Docker Desktop that allows you to do a lot of the work without ever having to touch the shell. You can start and stop containers. You can look at logs. You can dig into what's in the container image and actually see the files. You can do all that from the GUI. So that's normally my first step is like, let's get you with that set up. Let's get you in a Docker Compose file and describe your app. And let's get that working locally. Now, granted, the database and the Windows monolith might still be on remote servers or on something outside of your Windows Linux VM, right? That's fine. You're probably going to have some environment variables to set in your apps that you point it to the DNS name and the port of wherever the other parts of your app lives, as well as your database connection, right? Your database connection string is probably an environment variable. It is the thing in containers. You want all of that configuration stuff that has specific settings for specific environments. If you have to change something in CI versus production versus development, that should be an environment variable, because environment variables are the only thing that Windows, Mac, and Linux all share. Like they all have the same way to set and use the environment variables. And so not Docker specifically, but the DevOps community 15 years ago sort of decided the environment variables are the lowest common denominator for sharing configuration settings. So let's do that. And if you have like a MySQL config file, there are now scripts that will take all your environment variables, automatically push them into the MySQL config or the whatever your config might be, right, of choice. And those scripts will help automate that so that you can set environment variables. Like you remember the compose file, right? The compose file I had environment variables. So each one of these well, that's a bad one. That's not the right one. It's this one. And here, these environment variables down here, I only have like one. Okay, do I have none? This was not the right example to look at. Here we go. Like right here. Yeah. Most of my apps would have like 20 or 30 of these. And it would be telling me the environment variable for the DNS name to go find the API, the database connection string, the amount of Java virtual machine memory that it needs to use. Like you name it, all those types of settings that are resource-based, or which directory should I be saving these files in, all those different kind of things that would change based on which system they're running on. They should all be environment variables in here. And then when your app starts...
How do you manage those with your team? Like everybody has to manually put those in their environment. Do you have a central place to store them for everyone? Like, how do you handle that with the teams?
Yeah, so most of the time, if we talk about structure of a lot of these files, do you use .env files? Like, what's your standard now for?
Yeah, env, yeah.
Yeah, so a .env automatically gets picked up by Compose. So if you don't have to change that process. You can actually specify here different .env files if you want like a specific one to go to a specific container, or it'll pick it up by default if you just run them all in the same directory. So usually, if you're in a microservices like you have, and let's say you have 10 of it, like you said 20, each one of those repos is going to have its own Docker file that builds in container image for that app. And so you would have, like I said before, API 1, API 2, API 3, would each one would have its own container image. And then in one of those, like pick the main one, or maybe a separate repo. It's up to you. You don't have to make a separate repo, but that's where the compose file lives. And the compose file is for the entire solution. One compose file for everything. And you can actually use a feature of compose files called profiles, so that you can say like, start up the front end, and then it only starts the containers that you need to develop on the front end. Like I just need the API one, and then the web front end, and then the database, and that's it. I don't need the workers. I don't need this other thing, this job stuff. And so you can set up profiles, and each container would live in certain profiles, and you could just say, Docker Compose up. I think it's like -- profile equals, front end. If you're on if you have a front end, back end team kind of situation, so you can set all that up the way you want. And then it automatically brings in .env files, and you would just know that for local development, and on the server, when you're dealing with a single server, a compose file works just as good. Compose files don't normally work when you have a bunch of servers because, again, Compose focuses on the single Docker engine. So once you go to Swarm or Kubernetes is the default, what everybody uses. But I would argue that with your app, you may be able to completely avoid Kubernetes altogether. Like the goal would be if you can get it running on one server, then how do we run that across multiple servers without needing Kubernetes? Because that adds just a whole lot of complexity. And are you the one going to be the server admin? Are you going to patch the server, update Kubernetes every 4 months? Like, is that going to be your job? It could be.
I hope not.
It could be, but if you don't want to do that, then you have to adopt a cloud service to do this work, right? You can't if you don't you're either running it yourself or you're running a cloud service. Like you just have to pick your poison. And some teams are like, oh no, we want to run everything ourselves. We do it all. I'm like, great. I hope you have a lot of people. Like you're gonna have to do it all yourself. But if you start up and you say, I got it all working on a single server with a compose file. I can also run that compose file with different environment variables locally. It works locally. It works, and when I say works, it's like whatever your first evolution is. API 1 is the only thing running in Docker. Great. It's just one. If you get that one working and you have all the environment variables so that it knows where to go to find everything else, it knows all the DNS names and passwords and all that stuff for everything else. So it can run regardless of where you are. Like you can run in the cloud, it can run the same server, it can run on a different server. It shouldn't have to matter. And you're right, you'll have to care about DNS at some point. If you use orchestration solves the networking and DNS stuff for you inside the cluster. That's one of its jobs, is it figures out where to run the containers based on utilization requirements that you give it. Like I need so much RAM, I need this many CPUs. And so it'll find the right place. It's called the scheduler. And then after that, it's largely about, let me make sure that they can all talk to each other and any apps running anywhere on the cluster, regardless of what node it is. You never have to care about which node it's running on because the same commands, they all can talk to each other over DNS. They all have a clear path through the networking. And that's what orchestration is really trying to do for you. So you have a single CLI and you don't have to keep jumping on 5 different servers. Or you could just keep jumping all 5 servers and just do it like that with just Docker, keeping it simple, knowing that you're still trying to learn how to microservice stuff. You're still learning Docker and Compose. You're not trying to learn Kubernetes yet. Like that's a whole nother project, maybe for next year. And a lot of teams don't want to do that. They want to jump right into Kubernetes. And I try to push back on them and say, look, Kubernetes is great, but it's meant for you to run your own private cloud. And if you're not trying to do that today, then don't do that yet. Because it also means you're probably going to have to change stuff about your logging solution. You might have to change stuff about your monitoring solutions. Like backup solutions have to support the Kubernetes now. Like it affects everything. So you really want to try to push those decisions off as much as you can. Just focus on learning Docker. I would argue Compose is the way you should go. Everything Compose. And then if you get 5 servers, yes, if the containers are running on a separate server, you would have to have like DNS names, and if you're in a cloud, maybe you can use their own DNS. Like on AWS, you'd use Route 53. You don't have to make that DNS public. Like it doesn't have to be a public IP. If they're all servers inside of a VPC in AWS, then you don't have to expose anything other than the front end web port that users need to access, and then everything else can just be in the private IP subnets of that cloud.
I did do that once, actually.
I mean, we had Docker before Kubernetes. Like for years, we all had Docker, and we had to do it manually per server. So, you could totally do that. Oh, looks like we hit the bandwidth limit.
Oh, no.
There you go.
Here we go.
It only happened once.
It glitches out sometimes, yeah. It happened twice, but you didn't notice it, I think.
Yeah, because I'm on a soapbox, so I'm talking so long I didn't notice.
I was sitting very still. Yeah. I think I have a packet loss on my router.
Yeah. Well, this has been great. I mean, I'm sure you have a ton of questions, and we could talk for another 2 hours. But we do have to take a break at some point. So
yeah, I should RTF course.
Yeah, no, seriously. I mean, my course is designed specifically for people like you. Like, doesn't assume you know a ton of Linux. It starts off with the concepts and teaches you Docker through Docker Compose, and then eventually you get into like orchestration and like automating things with GitHub Actions and doing automatic builds for every pull request, and that stuff's all in there too. But you got to walk before you can run, right?
Yeah. Great. Thank you. I love it.
Yeah, man.
Thanks very much for your time. Wow. More than 2 hours now. That's crazy. Maybe take more questions from the chat there.
Yeah, we haven't had a lot. We had some questions earlier, but those people are probably all left.
Ignored them
Someone asked
long
about
enough.
someone asked very specific questions, which I don't have the answers to a lot of times. Like, our GitLab runners leave their volumes behind, and I have to delete it manually. I do not use GitLab, so I would be able to help on that question anyway. I'm a GitHub guy. Will Aspire drastically change the way like we containerized and manage our containerized.NET apps? I don't know what Aspire is, so I can't help with that question. Is that a .NET thing?
I never heard of it, to be honest. Maybe I'm not on the bleeding edge of .NET either.
.NET Aspire, an application stack designed to improve the experience of building cloud native applications. So if you heard that term, we would have called this all traditionally 15 years ago. We would have called this distributed computing concerns, right? Everything we just talked about, distributed computing. Then the word DevOps kind of took over, but DevOps originally was never really meant about tooling. Because we had no tooling when it was invented. The idea was invented. We didn't have DevOps tooling, obviously. It was just something that the entire industry latched onto and became a marketing buzzword. But originally, it was really about the mindset of let's measure everything. Let's measure how long it takes from idea to deployment. How many times a day can I deploy? How many people does it take? Can anyone deploy? Does it only one person is allowed to deploy? Because ideally, you want to get so that it's safe for anyone to make a PR. If someone else approves that PR because they reviewed it and you have that process down, then in theory, you should have enough tests in your code. You should have enough automation so that it just deploys. And that's easier now than ever with containers. But when DevOps first came out, we didn't have containers. So we had a bunch of extra tools back then. Chef, Puppet. We had all these automation tools that were trying to help us manage infrastructure as well as manage deployments. But it was very brute force back then, right? We didn't have a lot of these easier tools like Terraform. And Terraform is now, like, if you're trying to manage, to me, honestly, you learn Docker, you get containers running in Compose, and then you sort of pause there, keep working. If you need, keep working on your microservices, right? It's more important probably for you to work on microservices at that point. And then I would have a series of choices for you to make of like choose your own adventure. And we would say, okay, I would like to be able to build automated testing. You mentioned Jenkins. I'm going to move you away from Jenkins to GitHub Actions, because GitHub Actions in every way, in my opinion, is better than Jenkins. And it's far less work. It's far better for your team. Everyone can get involved versus Jenkins, which is cryptic and usually ends up with one person knowing how to manage it. And you don't have to run your own infrastructure. You can run it all in the cloud if you don't want. Or you can
We
run
already
your own.
made that decision. We already made that decision because our Jenkins guy left. So there you go.
Yeah. Yeah. So that's what happens and then Jenkins has been it's usually a very siloed piece of technology. It's hard to back up. It's hard to restore. It's hard to have it like build a new system if the old one failed and you have all the same plugins and everything. It's very 2000s technology. Not that it didn't have its day, but GitHub Actions and things like it, like GitLab runners, there's 1,000 CI providers, but GitHub Actions is just anything you want to automate with your code. But GitHub Actions isn't great for automating your infrastructure. So if you were trying to say, we want to spin up new servers all the time, or we want to spin up load balancers when we deploy a new microservice, and we want to have all that automated. So even when we create new microservices, nothing needs to be done and it just all figures it out. A lot of times that will all require Terraform, because Terraform, and to a lesser extent Ansible, are the tools for automating cloud infrastructure and adding DNS changes or adding new servers or scaling up and scaling down physical infrastructure. Those are all things for the infrastructure tools. But if you're just running a couple of your own servers and you're fine with that for now, then don't try to implement Terraform and Ansible. Like, that's a whole nother world of ops stuff, of sysadmin stuff that I try to get people to avoid nowadays. Like, the goal is, like, for me, is get you on a cloud and let's fully invest in using all those cloud services for containers, everything containers, and everything that cloud's services, so that we don't need a bunch of servers with shells and we have to patch them and reboot them. Like, I don't want anyone to have to do that anymore. But you got to walk before you can run, like you said, right? You got to start where you're at. So having a couple of servers and spinning up containers, and you just happen to know that server 1 has these 3 containers running and server 2 has these other containers running. That's the way, and then at some point you might want to say, well, I want to run containers on both servers for load balancing purposes in case one server goes down. If you don't want to do orchestration, which that's one of the things that orchestration solves, you would have to have a load balancer, right? You have to set up some sort of load balancer in front of those servers, that then you would have the containers running on both servers, the same containers. And then the load balancer, like at F5 or some sort of cloud load balancer, would have to send packets to both of them. It would have to, this connection goes to server 1, the next connection goes to server 2, and so forth. And that's also very traditional, right? That we would have done that a decade ago before we had orchestration. But now that we have orchestration, it also automates the load balancing so that you don't have to know which server the things are running on. You just specify how many to run and what RAM and CPU requirements they have, and it handles everything else. You can even tell it what names to use, and it'll figure out the DNS naming for you as well. So, but that's a lot. Like, you have to implement each thing one at a time. And so to me, the key is like getting you on Docker and just running one thing, if just one thing, on a Docker engine on a server somewhere, and getting used to that. And like, how do you update that? How do we make that update easier? How do we automate that update so that when you accept the PRs, that it's at most, it's just a one button click from there to, 5 minutes later, it's on my servers, or 30 seconds later, it's on my servers. And that's the idea, is like, we automate a little bit, more. I have examples of that as well. So instead of shelling into the server and typing a bunch of commands, how can we just have GitHub Actions do that work for us? Yeah. But you don't have to do all at the same time.
There's one more concern that we have in planning all this, that, like I told you, that our current platform runs on 20 countries, and different countries, different e-commerce stores, different regions in the world. So what we did so far is we bought a server in these regions and kind of grouping them, running on those servers. Now, with this new architecture, is obviously I'm going to work now towards getting one running, right? One full, let's say a full copy, let's call it, of the whole thing running at once. But with all these microservices, we think, okay, not all 20 need all of the APIs running. Like, let's say we end up with 10 applications. Obviously, the front end app is going to be a single copy for each country. Obviously, the back end is going to be a single copy for each country. But then we have some services that we may be able to group for multiple countries. Let's say in the same Latin American region, we have several. Then they would be using a single one instance of this service called, let's say, the mail queue. We have a email queue that goes out, sends emails out. Okay, we don't need a copy of that for every single site, because they just compose this little email message, and send it to the queue, and it gets sent out, right? So that is also something that not the entire infrastructure is going to run 20 times, because we'll be able to group some of them. And I think our biggest one is the login service, the key maker, we call it. Like the guy from the Matrix. So you get tokens, you get API keys, you get sign-on tokens that expire, and all those things. And then we thought, okay, I don't think we need to run one of them for each country. We might be able to group them somehow. So we're just maintaining one. Yeah.
Yep.
So it's
these
things.
And that leads so people that, like, you're talking about, that's application architecture. But when you do that kind of design, it does eventually get affected by your infrastructure decisions. And one of the challenges with application architectures engineers is, if they're completely ignorant of all things infrastructure, they don't really understand how their application architecture needs to be designed. So most good application architectures engineers, people that are deciding, like you're having to decide how many SSOs do we have? How many, where do we put these things on the global scale? That also requires, unfortunately, for that person to understand cloud infrastructure, container design and limitations. For example, Swarm and Kubernetes are not designed to run that cluster of servers worldwide. They're only, when you run a cluster, you're running it in one data center or one region, and at most you can have different zones. But most of these orchestrators for containers are designed for sub 10 millisecond latency, which the only way you're going to really get that is in the same region. You can't really get that across regions usually. And you can account for fault domains, but you can't necessarily have parts of a Kubernetes cluster on different sides of a firewall. Like, they're all meant to be well connected and without firewalls in between the nodes, and they're all together in a place. And if you need to have a bunch of regions, that means you're going to have an orchestration cluster per region. If you were to run all of your own stuff, right? If you're like, we're going to scale up, and obviously if you're going to run Docker in all those places, you've got to log in all these different servers, install Docker, and do all that. But I think a lot of times people think that Swarm and Kubernetes are like these panaceas. They solve all problems without limits, and not really. They actually are designed to just be in a single data center, or in a in a specific region without firewalls or barriers between them, and there are increasing number of solutions that are things that manage many clusters, but it's an extra tool. That's another thing that you would have to learn, is like, okay, now I've got 10 Kubernetes clusters in production, much less another 10 in test and dev. How do I manage all of them? And that's a whole another set of tooling that you have to solve. But at that point, you're creating your own clouds. You have to worry about storage. You have to worry about backups. You have to worry about all that stuff, which is why I try to always get small teams, especially when there's just one or a few people. That's the rules. We never install servers because you don't have the staff to do that. Even if AWS is more expensive, is it more expensive than an engineer? Because that's probably who you're going to have to hire if you don't start using some of these cloud services like that provide you the ability to run containers without ever having to worry about Kubernetes. They automatically update. They don't require any shelling in or any customization. They configure it all for you. And you're just like filling out a web form on AWS. And it's kind of like, I don't know, it's kind of like the old days of IIS where you only had like 5 or 6 options in IIS, and you would configure different websites, and you could add multiple IP addresses to the host, and you would like drop the little drop down and like, I want this IIS website on this IP address on this port. Like, you had very few options back in the day. And that's
They use
kind of what
SNI nowadays. Yeah.
Yeah, and that's kind of what you want
Yeah,
to
I
turn
think
into.
like Conrad saying in chat there, I think we will probably need to take the same approach like we do with the servers nowadays to create a different cluster or different, in a different region. I was just checking now to see if AWS have anything in the Latin American, and they do have availability zones there. So we might choose something like, I don't know, Colombia probably to run our own
Yeah,
cluster there, and all those sites would be there, because they're all around.
yeah.
Yeah.
Well, I'm looking forward to being on this journey with you and like getting, because we talk weekly since we work together. Um, but we don't normally talk about your development work at work. And I'm looking forward to hearing the progress of like getting that compose file working, because I think that is actually pretty critical. Because if you were ever to do anything beyond that, like Swarm or Kubernetes, you're going to have to build these files that describe everything about your app in YAML. Like, you can't avoid the YAML. If you're in the world of operations nowadays or deploying anything, you got YAML. So, the Docker file is one thing. It's a totally different format. Obviously, in no way, it's more of a shell script than YAML. But you learn that a little bit. And the reality is, with your apps, because they're .NET, your Docker files are going to be like 99% the same. Once you've got the one nailed down for one of the microservices, that same file is going to be the same thing across the other ones. The only thing that might be different is you might upgrade your .NET versions differently. You
I
might
doubt
have
it.
different. Yeah,
I
mean,
doubt
who
it. That's
knows?
what I was telling
Yeah,
you about, that blueprint that we are looking to get down. We're looking to get down a blueprint for one of these applications, because really, like, 2 of the applications are going to be the UIs, and everything else is going to be these APIs that we're going to talk to, and they're all going to be deployed the same way, the same language, same infrastructure, same, well, not infrastructure, same the same way, really, all of them having their own database in the back end, but really all the same. So if we get one, that's what we're fighting to get one
Yep.
of them to run nicely, to understand, for us to as a team to understand what it does and how it's being deployed, and then really all that's going to be different in them is going to be the C# code that's going to do different things,
Yeah. Yeah.
you know.
With different
That's
business
really,
logic and different
yeah,
dependencies. Yeah. And
yeah,
um, yeah. And so that's often what will happen is when I have teams that are deploying new microservices, they just copy and paste an existing microservice in their compose file. It's probably like
yeah,
10 or 20 lines of YAML. They just copy and paste that um, into the list essentially, and then they do a Docker Compose up, and then it spins up everything, including that new one.
yeah.
And
I think our
um,
progress right now looks like this, which is that's like a flat line, little blips. But then once we get this going, it's going to be
yeah,
like this. Hey,
that's
we're
and that's the thing about that's one of the we call it infrastructure as code now, infrastructure as code, IaaS. But what this really is doing is you're codifying all the settings and parameters for your app in a single file, and then later you'll be able to, like, if you want to adopt Kubernetes, you'll have to use a different YAML format, but you'll already have all of the information, like which environment variables matter, which ports matter, do I need volumes, and where do they belong? Like all those concerns were there before. You've had those today without Docker, but you might have some settings that are in the server config, and some settings that are in the app config, and some settings that affect it, because ports, you might need to change the port depending on where it's running. So you might have to go change a config file. So all these things were in separate places before. And the nice thing is the Docker file becomes kind of like the documentation for how to build and run this app, right? Because if you have a front end app, you might have more than one build command. You might have like something that minifies as well. So you might have other scripts that run all your build tooling and minification and rendering assets and all that kind of stuff. Well, that's all got to be in the Docker file because it's the only place that all of those things will also exist. So I've seen apps, for example, that they're using NPM front end tooling with a .NET as well. So now there's like a .NET build command, and then there's an NPM command, and so they end up with 5 or 6 different areas of their Docker file where they're copying different files around, and if you make static assets, you maybe have to delete the originals or whatever because you only want the things you want to go to production, right? And all of that stuff before Docker was some things were in our notes, some things were in the server team's server config documents, some were in this place over here, some were in a config file that we keep in this directory that's unique to this app because we named it 10 years ago. Like all those things go away because to me, the Docker file becomes how do I build, test, and run this app? Like it's all in that one file. It's not the best file. It doesn't have all the features everyone always wanted, but it is at least one place. And we never really had that. Me as a server admin, I always had to go find Word docs of the screenshots. So people were like, how do I configure the IIS? What do I need to do to install the services? Because you might have built custom .NET, Windows services that I need to install with DLLs. I have to have all these different commands. And it was a screenshot. And now
we have that in
you get to do it.
Confluence.
Yep.
We
And
keep
so
it in
now it's the
Confluence.
Docker file. That's the nice, it's like, it is the documentation, I feel like, because it also includes the ports. Like what ports do you run on? Where do the log files exist? If it's putting logs into log files, you have to make sure you get those out of Docker. There's this whole thing you can read about it in my course. Where your app now just needs to send your logs out of the app into standard out, as we call it, because that's a standard way that Linux gets logs out of the app. You don't need logging libraries like you used to, where each part of the monolith app writes to a different log in a different directory. Like you just get rid of all that, and it all can go away. And then every single app you ever make from now until the end of time, until we replace containers with some new fangled technology, is you just send things to standard out or standard error, 2 different places, one for errors, one for regular logs, and then you let the log system handle it, which is not your app. And I for years I was building advanced logging systems and apps, so we would have different different files for different purposes and different locations. And then we had to worry about, do we have write permissions in that directory? We on Linux we don't, because we did on Windows, but the Linux permissions are different. Like all of that goes away. So I give you hope that there are lots of problems that eventually get solved in your new standard that will make it so much less complicated for starting a new microservice and having to make 1,000 decisions about, what port does it run on? Where do the logs go? Where do the files? What's the file structure look like? What dependencies do I get? Where are my dependency installers? I need npm installed. I need this. Like all of that gets solved by Docker, by using the Docker file. So I give you hope, sir, that
Thank
you're
you.
not that your pains of today will be gone. Just don't adopt too much, and that's, I guess, the message for the internet is like.
Oh, I'm getting fired up. Following
Yeah.
your words, getting me fired up.
And you're going to go
Yes.
back and have to struggle with traffic, which it can be complicated. But like 90% of what you would do with traffic, you can do it locally without having to worry about a server. Because a lot of times with servers, you're dealing with firewalls or VPNs or other kind of stuff like that. So that's why I try to get everybody focused on the compose file. Because if you can get it working there.
I think the one thing that gets me discouraged is really this unknown of kind of, am I using the right tool? Do I need to use this tool? If I do, then why now? Or why do I need to be the one who learns how to use this tool? So
we've mentioned Docker.
Yeah,
So we've mentioned Docker. We've mentioned traffic. So we know you're using that. I've asked you to use Docker Engine and Compose. Specifically, pick up Compose if you're not using it, because you're missing out. It is Docker. It is built into the Docker command line. It is a part of Docker. So think of it as anytime I need to run more than one container and I don't remember the whole Docker run command, that's what Compose is for, because you can put it all in the YAML and never have to remember those. I don't ever run Docker run blah, 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 blah. Like I just don't do that anymore because I have Compose. So every single project of mine and every one of my clients, they all have Compose in there. So what other tools are new or that you're considering or you're dabbling with and you're not sure? Do you have you're not messing with like things like Terraform or Ansible or Chef or Puppet or anything like that, right?
No, we have a couple of more which they're not really infrastructure tools. They're more like for development. So for example, we have a search engine that's based on Elasticsearch. I am very frustrated with them because they deprecate stuff so quickly, and we're still running version 6.8 now, because moving to 7, they deprecated the whole way you build the index in a way. So I'm like, man, I can't keep up with this. And the second one that I'm considering now is Cassandra, because we have been collecting, 20 countries, and we've been very much disappointed with the way that Google implemented their GA4, the Google Analytics, and we are trying to move away from that. And because we have nothing else to do, we built our own analytics solution. And we're collecting literally millions of rows of data, like page views. What should we do? Our monolith wasn't big enough, so we thought, how can I make my database blow up? Oh yeah, I know. I'm going to collect everything that happens, every click everywhere. So so we're considering Cassandra for that, and that was one of my questions. Do you from your experience, do you think it is a good solution? And I've been reading about it, and I think it sounds like a good tool for multi-region, multi-whatever, and it just can take anything, any amount of data you throw at it. So that's one way that we're looking at.
Yeah, that's a good question. I have never run Cassandra, so I've never had to deal with it. But Conrad in chat is saying, yes, Cassandra is really nice for multi-region data store.
There you go. Thank you for that.
Yeah, Conrad's a regular. So definitely, and he lives out in the bubble of Silicon Valley area. So he definitely would have a pulse on what exactly is going on. And I haven't had to, largely my role ends up being less as an application designer. I'm almost like, if we were in a bigger team, right? If you had like 50 engineers and you were designing architecture, I might be in that meeting, but I'm largely there to make sure that what people are trying to invent in terms of application architecture, like do we use Cassandra as a part of our tooling, specifically for our custom application parts, I try to make sure that, can we even do that? How can we automate that deployment, upkeep, maintenance? Like, how do I keep that thing on the current versions? How do I run it locally for developers that need to run it? So I'm more concerned on the tooling side of making sure we want to implement a new type of thing into the application infrastructure. How can I help people run that locally? How can I automate it so we can run it on the servers? How can it be always secure and updatable in a way that more people than myself know how to do it? So I don't tend to, like, for example, if you told me Elasticsearch, I don't know the latest version of Elasticsearch. I've run so many Elasticsearches over my career, and all I know is it's a beast. It takes up lots of resources, but I've never really developed against it, right? I just support the developers that need to run something like that, and I rarely anymore, luckily, have to concern myself with like being the expert on Postgres database replication, right? Which is, I mean, I used to be more on that side of things, maybe 15, like back when we were doing Microsoft SQL replication and mirroring, and I was the one setting all that up we didn't talk about this, but I also helped run an e-commerce team for the US's largest HOA. I don't know if you have HOAs over there, but Homeowners Association, like 20,000 homes. And they had their own e-commerce portal. You could buy tickets for the kids at the pool. You could buy event tickets for different things at the giant, it was almost like a city within a city of this HOA. And it was a team of 5. Like we had 3 developers, me as the everything else, and then one who was the project manager. So if you said I got to run a database server and I need it to be redundant on 2 different servers, I need to be super fast, that was me, even though I didn't have the expertise. So I had to do that. And then when the database queries would get slow, they'd say, well, those queries are slow. It's your fault. Buy faster server hardware. So then I had to learn about database tuning and indexes. And I had to tell the developers, hey, look, you're not indexing your queries, so everything is super slow. That's not my fault. So then I became like a quasi database administrator, even though that was not supposed to be my job. So
Man,
I certainly feel with people like you that are sort of saddled with every single problem because you don't have a big ass team where you can say, I'm going to give it to the DBA team, or I'm going to give it to the backup team. And I've been in both of those where you had teams for the storage and teams for backups. And it was super nice. You couldn't get anything done quickly because everything was a committee and everything was a meeting, but at least you had experts. And I think it's just the state of things nowadays is that we've made things on the surface seem easy, that one person can do it all. But the reality is one person can't. So when I'm working with teams like you, I very much focus on what we will not do. Like, let's not bother with that because it won't give us any real meaningful business improvements. So yeah, if you and I were sitting in the room and you were talking to me about new ideas for ways you want to improve things, I would be focusing on what's painful, what do you spend all your time doing, how fast can you get these software updates out. If there's a security vulnerability tomorrow that affects .NET and it's a critical vulnerability and it's going to affect every microservice because you're using the same .NET version, how quickly can you get that tested and then released into production, right? That's a measure of maturity. And it doesn't even have anything to do with what technology you do to do that, right? It could be shell scripts. It could be PowerShell. But a lot of times that's the maturity of a team, is how quickly can you react to change? How quickly can you deploy new features? How quickly can you recover from outages? And that requires that you sometimes do things like Docker or moving everything to Linux.
Yeah. I think our biggest pain is the search engine, and talking about, building against Elastic. I can think of another word starting with B to describe it, because it's just a complete pain. And with 20 countries and probably, I would say, more than 10 languages, I would say 15 languages altogether, developing in Elasticsearch with multi-language, everybody has their own opinion of what a search engine should do. And as much as I tried, it took me a couple of years to develop the search engine, and I think it's great. It's fast. It uses relevance for scoring and all those. It doesn't do filtering like some people want it to do. And it's really the hardest thing ever to make everybody happy with the search engine. It's crazy. It's crazy stupid.
Yeah.
I have nightmares about it. Here's a final question, if you have more time. And boy, you weren't joking about these things going on.
I told
3
you.
hours. Yes.
Longest meeting ever.
The final question I had, which is a bit of a nebulous thing is how do you deal with backups like I know you can go into the cloud and everything's in the cloud and back it up, but like imagine we have these 10 APIs that we're talking about, right? 10 services. Each one owns its data.
Yeah.
Each one has to do a backup of that. And plus all the other things. So I know that there's this fame about Docker of things containers being ephemeral, and hey, you can destroy them as easily as you can build them and instantiate them, and they all go poof. And I know there's persistent thing and volumes and things like that, but beyond that, is there a tool I should be looking into for backing it up? I mean, I'm not talking about backing up the actual Docker files,
Yeah.
backing up the actual data that is now floating around all these containers everywhere. What would be the first thing to look at for that?
That's a great question. Um, so conceptually, let's back up a second, and we're going to go back to what I would call DevOps first principles, which came from 12 Factor largely. So there's this website. I give it to everyone. I make every single team I work with read this. If they don't know it well enough that they've read it through, it's literally going to take you like an hour to read through it. I mean, most of these pages, it's like 12 pages because 12 factors. Each page is less than a freaking each one of them is less than a page. But this was written in 2008, I think, maybe 2007. And this is the fundamentals for where DevOps came from and where cloud computing and distributed computing holds its values. It talks about separating out code from data, separating out your application code from environment configuration, like these concepts of like these different things. Because I don't think traditionally we, as in the computing industry, we were good at describing those things, right? You would kind of, if you wanted to think about concepts of applications and application architecture, a lot of it came down to what does your application, like what does it support? What does the .NET framework support? Well, it wants this type of config file in this location, and only these things can be put in the config file and not all of these other things. And you can develop bad habits and do all that. So one of the things that Docker did really well is it separates the concerns of ephemeral read-only code, which is basically everything in Git, right? Everything you put in your GitHub, versus data. And data is anything that I have to have if the server goes down and burns in a fire, right? Like if I'm running on one server and that server, I have all the source code. If I'm doing Docker builds of each repo into their own application images, those are also all on Docker Hub or GitHub, which everybody has a container registry now. There's hundreds of container registry options because container registries are the new artifact store. If you've ever used something like JFrog Artifactory, like the Docker Hub experience of you can put more than just containers in there. Anyway, every artifact that you would ever put on a server can now really live in there. And you have that, which means you give me a brand new server, I can do Docker run, however many times. If you have 12 apps, let's do 12 Docker runs. And now my app is running. But I don't have all the data. And so we need to define where your data lives and what type of data that is. You might have some file data. You might have some, traditional MySQL or SQL data. You might have,
Static
you mentioned Cassandra data or Elasticsearch data. And each one of these is going to have their own backup commands, their own backup expectations. Docker is not like a backup solution, right? Not really. It doesn't understand. It just runs binaries. That's all it knows how to do. It knows how to talk to the kernel and isolate things and then run a command, which you type into the Docker file under CMD, right? You type the command out of what it needs to run, and it just knows it ran that. That's all it knows. It is super dumb. It's not somehow like aware, oh, you're running a database, I need to do special things for the database files. It doesn't know anything like that. It's way more basic than that. So your database rules don't change. Like if you need database redundancy, then you need to figure out a database redundancy plan. If you need to back up databases, then you need to figure out what database commands that database supports, and you need to run those on a regular basis. Now, Docker can help you a little bit by allowing you to run those tools in containers or allow you to bind mount locations on your backup storage solution into the container to get the files out. But it's not going to miraculously back up and restore all your stuff. So one of the first steps is you define and tell me in a list precisely for each one of your applications, what are its data concerns, and what type of data is that? Where does it live? So in the case of your API, I'm assuming it's not writing files to the hard drive. Is that a fair assumption for your APIs? Right. One of the things of the core tenets that's probably not well defined in that 12 factor that should be nowadays is we had this conversation in the last couple of years at KubeCon, is that really developers of server applications like yours assume there's no file system. Assume you no longer have access to write files to the hard drive. Assume that it's always read-only. Because when you do that, we're all used to like cheating nowadays, but before distributed computing, it wasn't cheating. It was you have an app on a server and everything is on that server, right? You like literally everything you need for the app is on that server. The database is probably on that server. So you're used to like writing temp files, writing caches, writing session state back in the old days where we'd write session state to files. We would write all that to the hard drive. But we've now in the cloud, it becomes much more painful to distribute your app. It becomes less flexible. It becomes more rigid of an infrastructure if your apps expect to write files to a hard drive. Because whether that's logs or anything else, the minute you have to do that, suddenly now you have to worry about volumes, which adds complexity because now you're talking about, well, where does that file get stored? What's the speed of the disk? Like all these things that you just don't have to concern yourself with anymore. Now, if you have a database server, presumably if you're in the cloud, you're running their databases, the cloud's databases, which means you don't have to worry about backups as much. I mean, you still have to enable it, but they're going to do redundancy. They're going to do backups and restores. They're going to, manage, make sure that you're getting the performance out of that thing that you expect. But if you do all that in Docker, which you can, it's no different than if you did it on your own server. You now become the DBA. You now have to optimize disk location, speed of I/O, caching algorithms, all the different things, like every minutia configuration of the database. You have to do all that yourself. That doesn't change with Docker. You still have to do all that in Docker. It just makes it easier to like run a database because you can do Docker run MySQL. You don't have to do like apt install MySQL and all that stuff, right? You can just do it with a Docker command. But it's not magically going to make databases more resilient or whatever. So for your apps, my goal with your team, especially if you're completely rewriting these things as microservices, is the rule is they have the only access they have to the file system is read-only, which if you can possibly do that, it makes it so much more secure. There's a whole class of security vulnerabilities and applications and frameworks that you would not even have to concern with, because so what if someone can hack into your website code? If it's to be able to write files to the hard drive, well, you can run the container read-only so that it can't even write a file. Even if they were to be root in the container, they can't write a file because the outside OS is preventing any writes of files in that container. Now, not every application can do that, but you should start from that approach and say, does this application even need an exposed app port to the internet? Does it even need write to the hard drive? And if you can get away with that, suddenly everything else after that becomes easier. It might make your application design a little harder, but it means that you can run that container anywhere. You don't have to worry about the size of the hard drive, what permissions are on the hard drive, how do you back up those files on that hard drive. You can just not care. And so that's why we talk about the ephemeral nature. Is the first time that when Docker first came out in the first release of Kubernetes, they had they were like, everything you run in here is going to be able to be deleted quickly and go away with a Docker RM command. And then you create a new container and everyone's like, what about my data? And then they were like, well, you can make this thing called the volume, which is just a file path on the hard drive, nothing special. And then when you save stuff in there and you delete the container, Docker won't delete that data. So that's what a volume is simply a separate object in Docker, which is just a place on the hard drive, that it will store the files that you write or the files that you change, and it will store them there if you tell it to, and only if you tell it to, so that when you delete the container, the volume is left alone. Volumes are a separate object. So like when you go look at MySQL, that's a great example, Postgres hub. Let's go to Docker Hub and look up. You said you were considering Postgres, right? But you were looking at Postgres.
We're already using it. We've installed it already. It's all set up. The application writes to it. The one that we got to run, at least.
Right. So if you look at these examples here, it talks about environment variables. Like when you're on Docker Hub and you read all this, like this is the manual, right? It's the README page of this official image of Postgres. But if I search down for volume, it will say, how do you? It's talking about the environment variables, and it says PG data. Normally, data is stored. All the databases in the database logs are all stored in var lib Postgres SQL, and specifically in this path. So when you run your Docker command, you've probably done this, you do a -v, and there's 2 or 3 different modes, depending on how you want the data to be stored. But you're basically saying, store this data in this location in the container. We do something called a mount, which is a Linux concept. It's a shortcut in Windows, or similar to a shortcut in Windows. And you're saying in the container, I want it to be in var lib Postgres data, so that the Postgres database in the container can write to its normal location that it's expecting to write to. But it's really mounting that location. It's not a copy. It's just pointing to the same files. But on the host, it's actually going to be here. That's called a bind mount. You learn all this in my course. But that's a bind mount, so that you would then have that data outside the container, so that when you delete that container later and upgrade to the next version of Postgres, so you're replacing the container with a new version of Postgres, you would still have the data, and it would just come right back up with that same data, because it would have the same configuration here.
That is the data that you actually back up.
Yeah. Now, because it's Postgres, you can't really just copy those files. That's not how database backups work. You got to run a database export command or whatever the PG backup, and that's just a standard Postgres thing. But what you would do is when you ran that, you would tell it to put the backups in one of these volumes, so that backup would live outside of the container as well. And when you're in a container, by the way, the application doesn't know that these are bind mounts to different locations on the real hard drive. It just sees a file system, and it doesn't really know that these are special locations. But ideally, you're not running your own databases, and ideally, you don't have to deal with backing up your own data, that hopefully a cloud service is backing up your Cassandra and your Elasticsearch and your, all that stuff. Otherwise, you have to go find what scripts do they use to back it up? How do I automate that? And there are at scale, when you're talking about hundreds of containers and lots of complicated stuff, there are Kubernetes aware backup agents and backup tooling that exists. So you can tell it, hey, this Postgres container over here, make sure that its data is back up, and make sure to use the Postgres commands for properly giving a stable backup copy. And so you would still have to do all that stuff. It's still work, which is why I try to get people out of not doing it. I don't want you to do it.
Yeah. No, I mean, that's this is the other point of view that I have, the attraction of running your own server, because then you can rely for a nonprofit organization, which we are. It is very attractive to be able to say, okay, we're spending, I don't know, $10,000, whatever, a year on 3 servers, fixed cost, and our team deals with making sure that all the applications run fine within those confines. If you go to the cloud, then you say, oh, Cassandra, boom, turn it on. Yes, Fice Postgres. Yeah, just get it running, And they charge you by hour, by whatever you're paying with those. So the costs become not unpredictable, because they make it easy for you to predict what's going to be like, and they tell you what it costs to run this whatever. But they become more flexible, the costs.
Sure.
And you go suddenly at the end of the year, you spend $20,000 to run the same application. So hey man, last year you managed with 3 servers, 10,000. This year it's double that. What changed? Well, not really, nothing. We just rewrote everything. And we moved it to the cloud. That is really a big consideration for a lot of these decisions behind designing this whole application. Also the cost, not just the technical. I know you're spending on an engineer, like you said, and you got an engineer who takes care of all these things, and that's the cost. But also the cost of running in the cloud is higher, we found, just for the monolith. And I'm sure it's just
sorry, I didn't mean to interrupt. I thought you were wrapping up. Sorry.
No, the monolith, we actually got it running in the cloud completely for a month. And at the end of that month, we were like, no, That's not going to work. Go
Yeah.
back to bare metal. Maybe it's the same in this.
Well, and that's the thing about, okay, so this is a great, also a great discussion. This could be a whole episode, but like realize that you're I think you're fully aware, eyes wide open, that every one of these pieces of tooling, there is at some point there's a choice of run it in the cloud or run it ourselves. Now, running yourselves could mean on your own hardware in a cloud in your own data center, but it ultimately means that you're responsible for things like monitoring availability, log storage, backups, restores, and every one of those is a choice. And only you and your team know the budget, the propensity for the company to spend money on infrastructure versus people, because I can tell you, like, every organization is different in that way. Some happily hire a new DevOps person, happily go through the months and months of work to find the right person. But in order to spend any more money on AWS requires a whole new budget, wait a whole another year. Like that's maybe their approach. Other teams, completely opposite. Like buying into server infrastructure, very easy to do. They can do it on their credit card. They don't even need like special permission from budgeting. But to hire a new person, oh man, that's a very big deal. So we are optimized for infrastructure and automation on the internet and very few people, right? So we're dialed in to like the latest, most efficient automatizations. So we're probably using Terraform for all of our provisioning of server infrastructure. It ultimately means you have fewer people, and those people have to know a lot. They have to be really dialed in. Or I find teams that are they have more people. They're because they have more people. They have a less tendency to automate out of a lot of things because they have the time. They have people that they can delegate stuff to, and so those people do that stuff manually. And they're not so paranoid as one person might be, where they're like, well, this is a little inefficient and it requires a little bit of work every week, but we've got people to do that. So I'm not criticizing either one, because I've worked with both and they're both great. When you automate everything and you're using all of these latest tools for consolidating infrastructure, optimizing your billing, there's all these tools for all that. But that means that very few people have to know all those different tools. With a bigger team, you can spread out the work, right? Not everybody has to know Docker to the nth degree. Maybe everyone knows how to read a compose file mostly, and then there's one or two people that really know like how to make a Docker file from scratch, and they know how to start a Docker compose file from scratch, and they know how the engine actually works, and that really all it is just a bunch of tarballs and metadata. Like those people can be leaned on, but when you're a large team like that, not everyone has to know, like everybody has their own expertise. So I've seen it both ways, and I don't even know that there's really the right way. It's just, this is how your organization is set up. They're not set up to hire and fire. So we're limited to the two people. So then you have to start making decisions like, do we want to run it ourselves? Well, we're already working 40 hours a week and we're completely busy. And there's all this new stuff that we've got to do, but we have no time for it. So the answer can't be, let's set up more servers and maintain them ourselves. Right? Like you're forced to say, like, I have no more time. I have you, and you have to beg and steal from management. I need budget to go buy the Postgres service that AWS charges a premium for in RDS, and you just have to live with that because you know that if you ran it yourselves, it would probably go down. And when it went down, it would be your fault that it didn't come back up in the next 5 minutes. So it's really just choice. And once you've made a lot of those choices, now you have to live within them. So the hard part I often make is like when you talk about logging or monitoring or backups, those are the immediate first things I want to automate out of. Like I don't want that job. It's tedious. It's boring. There's usually cheap tooling out there to do all of that. So, I would try to outsource that stuff. But hey, if you want to run your own cluster, great. But you don't have to run your own logging solution. You don't have to run your own. I'm not talking about your specialized front end stuff. I'm just talking about general container logging. You don't have to like implement Loki or Prometheus or any of these advanced open source solutions.
Stop telling me names of stuff.
Yeah, you don't have to do all that stuff. Yeah, you don't have to do all that stuff. So I think we should just end it with that. It's like you don't have to do it all. I think you're doing great. I think you're on your path, and we're going to wrap it up.
Thank you.
We're wrapping it up now. Beth's back. So thanks, Cristi. Thanks for being here.
Thank you very much. I really appreciate it.
Yeah, I will see you offline probably tomorrow. And we'll probably do another. We should do another one of these in like 6 months or something when you've got stories to tell and like more struggles and different pain points. Because I think this is good fodder for like the difficulty of DevOps and like how hard it is to culturally shift all of this stuff. Who knows? In a year from now, you're probably going to be like automating deployments and server automations, and you can scale up and down automatically based on load. And yeah, you'll get there.
Well, or I'll join with my new DevOps guy if we hire someone.
Or make him watch this video.
Yeah, here's the thing we need. Watch the 3-hour show, please, and let's talk.
Yeah, 3 hours. Watch it on 2x. Which means that it'll sound like chipmunks, but you'll get done a little faster. Well, we're hopefully going to make some clips out of this, so maybe we'll have some good solid clips that are just like little chunks of info. Yeah. So thanks, Max. Thanks, Conrad, for being here. Nubuo, everybody, all the regulars, Conrad, everybody. I think I said Conrad 5 times. Thanks for being here. We will be again live next week on Thursday, and this will obviously come out in some other fashion, hopefully, once Cristi and I figure it out. Hopefully we'll have clips. We're not sure if this will be a podcast yet, but we'll be live here again next week. Let me just tell you real quick before we go, who's going to be on the show next week. I know Cristi's like, okay, what other new tool are you going to give me? Next week, we're going to have Kyle on, who was here earlier. I'm not sure if he lasted all 3 hours, but Kyle's going to be here. We're going to talk about AI native cloud application security automation. That's a lot. Anonymous Plane. We'll talk a little bit about Docker Slim, which is a tool for helping you get slim images. We've got Traffic, the founder of Traffic, in 2 weeks. I'm sure Cristi's going to come on and to chat and ask some questions of the founder of Traffic, like, why doesn't this work? We'll have that on the show, so it'll be fun. And then we've got ML Ops. We've got more AI stuff coming later this year, so come back and join us on Thursdays. And with that, I bid you adieu. Thanks, Cristi. Thank you, everybody.
Thank you very much.
See you.